Good evening, everyone. Good evening, Ravi sir. So
Yeah,
today we have chemistry lecture for both the hours. So we'll proceed with the session now. Sir, are we ready to go? Ravi sir?
yeah, right. We're ready.
Yes. Okay. So students, please be in the meeting, and if any of your friends are willing to join, you can share the same link for joining and ask them to join. Today we have chemistry for both the hours. Thanks. Sir, yes, sir. You can proceed, sir.
Ah. Is screen visible, Nikesh?
Yes, sir. It's visible, sir.
Very good. Okay, right. Just enough. Right. Dear students, welcome back to our program. And today we'll be discussing chemistry in both the sessions. Okay. So what I will do is that I will try to split the syllabus into 3, 4 components so that it becomes easy for us to study and understand it. But before I go for the sessions, I want you people to know about the distribution of marks. Okay, what are the components are there? Whichever the chapters carries how much marks, and what weightage will I will give it to each chapter. Okay, so if you come to this particular uh, chapters, so how many chapters we are supposed to study? We are supposed to study about 10 chapters. In these 10 chapters, all these chapters have been mainly categorized based on all the questions will come based on certain things. Like there are some questions based on memory, remembering and understanding, and few questions on application, and few more questions on analyzing, evaluating, and based on creative ability of your okay knowledge. So those kind of questions will be there. So if you take the remembering and understanding questions, this will be more simple. They will be maximum 40%. They'll be there. That means easily you can approach the question paper. It's not difficult. The most of the questions are just based on your remembering ability and understanding. We call it as memory-based questions. So remaining 30% is there no? That is around 21 marks is based on application. And remaining 30%, so that is based on analyzing questions, evaluating questions, multiple concept questions, bit of based on your creative thinking. Those kind of questions will appear. Otherwise, the question paper will be very simple in nature. Okay. The first of all, the word difficult, you remove it. The question paper may be very challenging, but it will not be difficult. Okay. So all the questions basically are of 3 types here. Okay. Next, if you look at the chapters, what we are having, I told you, we are having 10 chapters. So the first one is solution, electrochemistry, kinetics, D&F plug and coordination. These are very simple chapters. Alkynes, alcohols, aldehydes, amines, and biomolecules. The first 3 chapters are physical chemistry, is it not? The physical chemistry, sir. This next one is 4 and 5. These are inorganic chemistry. And last 5 is there, this we can categorize as organic chemistry. So if you look at that, organic chemistry is having how many chapters? Sir, 5 chapters are there. 5 chapters are there. So in organic chemistry, there are 2 chapters are there. Physical, there are 3 chapters are there. So there are more number of chapters in organic chemistry. Okay, so what I will do is that today I will start my discussions with organic chemistry. Okay, in that I will start with the 2 chapters, the aldehydes and ketones and biomolecules. What we'll do is that tomorrow then I will take up few chapters in physical chemistry and few chapters in inorganic, so that it covers everything. And you should know the weightage of this particular chapter also. Okay. And as you can see, the more weightage is for electrochemistry. Very simple chapter. Tomorrow we will take it up. And then there is a more weightage on electrochemistry. And in organic chemistry, after that, the biomolecules are having more weightage. Okay. So then we will take up these two chapters. Which two chapter today? We will take up aldehydes and ketones and biomolecules for discussion. And if you take the entire question paper, so in this question paper, now you know that there are 5 sections are there. A, B, C, D, E. Section A, you know that one, there will be MCQ will be there. Sir, assertion and reasoning will be there. How many questions? Sir, there will be 18 questions will be there. How many marks will be having? Sir, 18 marks will be there. Is it audible, all of you? Next, in section B, 2 marks questions will be there. How many? 7. So what will be the marks? 14 marks will be there. A short answer type will be there. Very short answer and short answer. Section C, 3 marks will be there. How many questions? 5, 15. Then you will be having a long answer type or case-based questions. So how many marks? 5 marks, 3 questions, 15 will be there. And last section, you'll be having 4 marks, 2 questions will be there. How many? 8 marks. So totally, the 18 marks is from MCQ and reasoning. And subjective means very short questions, okay? Short questions and long questions, we call it as a subjective. 44 marks will be there. Based on case study, around 2 questions will be there. That is 8 marks will be there. So that is our question paper. Now let us go to, okay, how to prepare for this one. Okay. And first of all, the preparations should start with your positive mentality. Don't think what has happened till now, not to worry about it. Now just think ahead. Say if you have studied very well, think ahead. If you are not studied very well, also think ahead. Not to look back. So what I can do now? In remaining days, what I have to do? This is a word, you have to start with this. Immediately, say if you are sitting with my class session, immediately take a notebook and one pen. Don't simply sit like that. Take a pen and notebook and start noting down all the things what I'm giving. And for remaining days, please have a timetable. Without that, don't go ahead. It may be small timetable. It's not be a look for every 10 minutes, 20 minutes, 30 minutes, I'm having some session. No, don't do that. Just make a simple timetable. Say today, after Ravi Shankar sir class, what I'm going to discover, what I'm going to study. Tomorrow, so what are the things I have to study? Just make 3-4 sessions and start it. And say, don't try to grasp too many things at a time. It's not possible. Just start at one point. Say today I could have taken all the chapters. Purposefully I have not taken. I have taken only organic chemistry. Even in organic, I have taken those chapters which are having more marks, which are those aldehydes and biomolecules. In my first session, I'll be discussing only aldehyde. Then I'll go for biomolecules. So don't grasp too many things at a time. Just one chapter, just one particular topic, one particular subtopic. You start with that one. And whatever you study, make a note. Make a note. That's why I told you, if you sit with my session, please have a notebook and a pen. It's not only about hard work. You have to be very smart. Very smart. Means what? Say if you're listening to me, make a note. Then after my class, take a break. Do a small revision for just a few minutes. How much time is possible? That many. So I will do for 10 minutes. Do it. So I will do it for 50 minutes. I will do it for 20. As much as possible. Be based on your capacity. Do revision. then do a little bit of recall of what we have done. Today it has to happen. That is what I told you smartly. Today you listen to my session and do all these things after 3-4 days. No, it is not useful. Then after that, you'll be having many model papers with you. Take questions from there based on the topic what we have discussed. Say, today I'll be discussing about audits and nowadays so many books are available. Just take those questions, previous question appeared in audit, and go through it. See whether you can be able to solve it or not. If not able to solve, not to worry. You'll be having answer next to that only. Just look at the answer and practice it. And in between the session, please have a little bit of relaxation, meditation, exercise, whatever which gives you, relaxes you, mind you. That is what very important. It's not that, okay, you have to do this one, that one. No. One which gives a relaxation for a short break. Okay. And always try to discuss what you've learned. That's very, very important. So this is what you have to do it in the background. Say just before the exam. Say tomorrow is the exam. Sir, what I have to do? Please do revision of all the 10 chapters in chemistry. Sir, tomorrow is the chemistry exam. What I have to do? Don't study. So don't mistake me. I'm not asking you to study. No. The study, everything you have to do it before. When tomorrow is the exam, you have to do only revision. Just you have to go through all the topics and subtopics present in the chapter. That's why I told you, here is what your notes is very important. Your short notes will give you all the idea about the subtopics present in the chapter. Once you've done revision, close the book. Sit for 5 minutes and do recall. Recall. What is recall? Whatever you studied, just try to remember it. Sometimes we don't remember. We are not robots to remember everything. We miss something. Not to worry. Just take the notes again and see what you have missed it. And just try to recall. And before you go to bed, keep all the things required for exam. Don't say that, sir, tomorrow morning is the exam, so morning I will make ready. No, night only keep everything ready. And also this is very important. And tomorrow you're going for exam. They have given instructions from your college and in your hall ticket. Please go through it. They have mentioned everything, what you have to carry, what you should not carry. That's very, very important. And then need to have a sleep. I've seen some students directly, all night they study and come to exam. Don't do it. You mess up everything. Even whatever you have studied, whatever you know, that also you'll mess it up. Need to have one small break of sleep. I'm not telling you sleep for 10 hours or 20 hours. What I'm telling is that a minimum of around 6 hours, whatever you are comfortable, that sleep is required. So I told you two things. Before the exams, just before the exams, and during the exams, very important. So today you are attending the exam. Immediately what you do, keep your things on the table and read the question paper. Go through the instruction, what they given. Nothing will happen. You may lose 1 to 5 minutes, not to worry. That is important. And find out which question you are comfortable. And find out which question is having maximum marks. My dear friend, please first finish it off. Remember, all these things you come to know only if you read the question paper. Find out which is easy, which is carrying maximum marks, finish it off. Write it down. Sometimes while writing, you'll get stuck somewhere. Some questions you think you can write it down, but you'll get stuck. Not to worry. Not to worry. You leave that space. Nothing will happen. You leave that question, just jump into other question. Whenever you're stuck, not to worry. Just jump into other questions. Because you'll be, by thinking only, you'll be wasting your time. And whatever you know, just finish it. And then you come to those questions which you think you can attend. By the time your brain is having the capacity to recall everything, it will process. It has some links. It will be having some chain link. Or rating, when you keep on rating all the questions which you know and which you think having maximum marks, by the time you'll get the difficult question also. And my dear student, at the end, make sure that your answer paper is very clean. Okay. If you want to struck some questions, say you're just put a one line on that. That's enough. Say you don't want the sentence, just put a one line on that. Over. Don't they should not see it. They should not see it. Don't do all these things. Oh, you have to do like this. Do I have to do like this? Don't do all this nonsense. Just what you have to do, one line. That's it. You don't want this sentence. Just put a one line. The teacher will understand. Okay. And after each question, put a line. And no need a scale. Just put a hand. Just a line by a hand is enough, like this. After each question is over, you have written the answer. Just put a one line. That's more than enough. That will distinguish between each questions. That's very important. Make sure that your answer paper is clean. So over, everything is over. Still you have around half an hour. Don't run away. Sit there. Nothing will happen. This is your question. Main exam. Sit for 3 hours. Sit for the duration what they have given. And just review your paper. Whatever the answer you have written, is it proper? And the question number, say you have written 3A, you have to write. But you have written only 3. A you have written. You should write it down. If this is a question paper, on the left-hand side, proper should be there. 3A, 3B, you should be written properly. Review all those points. Then review your answers. What are the answers you have given? Review your answers. Say between two questions, you're not distinguishing between, put a line. All those things you can do it at the end. Don't run away. Even time is there. Sit there till last moment. See the first thing, whether you have sent the paper or not. Additional answer sheet you have taken, whether you have filled it or not. All those things. So these 3 things are very important, my dear students. What is that? This is how to prepare for your exams. I think most of the people will be doing it. And just before the exam, what you have to do. And during the exam, what you have to do. Then we'll go to our topic. So today I told you, I'll be discussing 2 topics. That is aldehyde, ketone, and carboxylic acid, and biomolecule. Biomolecule will take up by next sessions. Okay. Now we'll start with the aldehydes and ketones and carboxylic acid. And this chapter is very, very important because it is having a maximum marks in organic chemistry. So what is aldehyde? All these compounds, aldehyde ketones, they're called as what? Carbonyls. Sir, carbonyls. What is carbonyl? Any compound having a CO group, we call it as a carbonyl. So the aldehyde will be the CO group, right? Ketones will be. So aldehyde ketone, both are having CO. That's why we call it as what? Carbonyl. Okay. What is aldehyde? Aldehyde is a organic compound having general formula RCHO, where R is a H is equal H, alkyl or allyl group. What is a ketone? Ketone is having a general formula RCOR1, where R is a alkyl group or maybe aryl group. But it cannot be H. Here, look at here. Here, R cannot be H. Where in ketone? Only R is equal to H. Where at? Aldehydes. Aldehydes. Let us take some examples. Just a minute. So give me one example for aldehyde. What is aldehyde? It's CH. Where R is equal to H. What is the common name? Sir, formaldehyde. What is the UPC name? So there's one carbon, so we call it as what? Meth. And E should be replaced by Al, sir. They're called as what? Alkenols. Whereas ketones are named as alkenones. One simple example you give me, sir, CS3CO, CS3. What is this one? So this is acetone. What is the common name? Acetone. So what is the UPC name? There are three carbon atoms, sir. So it's a propanone. Propane. Where the ketone is present? At second carbon atom, ketone is present. So propane to answer. Next, what are the things we have to study in this particular aldehydes and ketones? First point, you have to study preparation of aldehyde. Sir, how to prepare aldehyde? By oxidation of alcohol. We know that any alcohol, when undergoes oxidation, it forms a aldehydes or ketone. Sir, oxidation adre, what it gives? Aldehydes and ketones. And aldehydes ketone further oxidation gives you what? Carboxylic acid. This we know it. So this concept we use. We oxidize alcohol to get aldehydes and ketones. How to do it? We can use oxidizing agent. Which are the oxidizing agent we are using? Potassium dichromate. Or you can take any kind of a strong or weak oxidizing agent. Yadra togodu, sir. Where alcohol undergoes oxidation to form aldehydes. Ketone undergoes oxidation to form, secondary alcohol undergoes oxidation to form ketones. Always remember, primary alcohol always gives aldehyde, secondary alcohol always gives us ketone. Then we can also obtain it from carboxylic acid. So how to obtain it from carboxylic acid? By catalytic decomposition. When carboxylic acid are subjected to catalytic decomposition in presence of manganese oxide as a catalyst, we get aldehyde. Same way, when we take carboxylic acid and the esters, in presence of manganese oxide, we can get ketones. What is the other method? So from hydroboration and oxidation of alkynes. What is hydroboration? Addition of borane. The BTS6, no, we call it as a hydroboration. So what will happen when we do hydroboration? This borane will attach to this particular carbon atom having a triple bond. Then further, what we have to do? We have to do oxidation by using what? Hydrogen peroxide. We do oxidation, so by using hydrogen peroxide. So what we get? Wherever this particular borane is attached, that carbon will carry OH group, sir. And then further, what will happen? This hydrogen will shift, sir, tautomization. And double bond becomes single bond, and we end up getting ketones, sir. So we call it as hydroboration oxidation of alkynes. Next, we can also obtain it from ozonolysis. So what is ozonolysis? Where we take a alkene. Alkene is made to combine with ozone. Then we get what? Ozonide. So we get ozonide. And breaking this ozonide is called as ozonolysis. How to break it, sir? By using water. What we get? So we may get aldehydes also ketones. Aldehydes also ketones, so we get it. If you look at this one, this is the alkene what I have taken. And the bond breaks here. The bond breaks here. When the bond breaks here, we end up getting what? Aldehyde also, ketone also. That depends on what kind of alkene we are having. So what are the two steps are there? First step is reaction with ozone to form ozonide. Second step is breaking that ozone. That's why it is called as ozonolysis. Next, so we can obtain from geminal dialytes also. We can obtain from geminal dialytes also. What is geminal dialytes? Two halogen attached to the same carbon atom. When we treat with aqueous KOH, we get hydroxyl compound which further decompose to give a ketone. So this depends on what kind of halide you are having. If you are having a vicinal dialide, we end up getting aldehyde. If you have a geminal dialide, we end up getting ketones. How this can happen? I'll just show you these things. I'll take you on board. Let us take one chalk piece, white chalk piece. Sir, how to get a aldehyde in this case, or first ketone will take. So you've taken a geminal dialide. What is geminal dialide? I will take CH3, CCl, CH3. This is a geminal dialide. First, what you have to do, we have to treat with aqueous KOH. Sir, what will happen when you treat with KOH? The OH will replace the chlorine atom. So we end up getting a carbon having two OH groups. We get a compound like this. So,
Excuse me, sir.
Yeah.
Sir, Arbia has a question.
Yeah, tell
Sir,
me.
which is that reagent's THF?
Which is the reagent?
THF.
Tetrahydrofolate. It's a solvent. It's a solvent.
Arbia, do you want to speak? I'll allow you to talk. Please raise your hand, Arbia.
Yeah, they can speak. No problem.
Yes, sir. Yeah, Arbia, you can ask now.
Good evening, sir. So, what
Yeah,
is a
tell me.
THF reagent?
Tetrahydrofolate.
And we use it for?
Is used as a solvent for a reaction.
Okay, sir.
Okay. The main component is B2H6.
Okay.
The main component is B2H6. And that's why the step is called as Arbia hydroboration.
Okay, sir. Thank you, sir.
What is the next step? Oxidation by using hydrogen peroxide.
Yes, sir.
But whenever we use boron, we use THF as a solvent.
Okay, sir.
Okay.
Yes, sir.
Right.
Thank you, sir.
And now come to this one now. So we got this compound. 2KCl has been removed. And when two OH group attached to the same carbon atom, it is unstable. In chemistry, two OH cannot attach to the same carbon atom. It is unstable. So what will happen? So then one OH and another OH will combine to form water. So what is remaining now? So CH3, CO, CH3. And what is the valency of carbon? 4. So we get C double bond 4. What is this compound? So this is ketone, acetone. So we got ketone from geminal dialytes. If I take vicinal dialate, we end up getting aldehydes. If you take vicinal dialytes, okay, and when you treat with aqueous KOH, we end up getting aldehydes. What is vicinal dialate? Where halogen is attached to adjacent carbon atom like this. Got it, all of you? Everybody, any doubts? Good. Good to go then. Next one. So this is the preparation of a aldehydes and ketones. Okay. Then there are many reactions are there for aldehydes and ketones. Okay. What I'm given is a very simple one, important one I have given. So what are other reactions? Can you tell me? I just make a one small board for you. I'll take chalk piece. Say, let us say, let us discuss about aldehydes and ketone only preparation. You can prepare aldehydes and ketones by, you know that one, Rosenman reduction. So we can prepare it from Rosenman reduction. Okay, by taking acyl halide and by taking a catalyst, which is the catalyst? Palladium, supported over barium sulfate and poisoned by sulfur. So from Rosen reduction, you can get aldehydes. Then what are the other methods?
Stephen reduction.
Yes, Stephen's reduction. What is Stephen's reduction? Where we are taking cyanide. Sir, we are taking a cyanide and converting it into aldehyde by using what? Stannous chloride and HCl. Then we can, sir, we can get aldehyde by using Itard reaction by taking what? Taurine, sir. Taking taurine. Then we can obtain aldehyde by using what? Sir, Guttram and Koch reaction. So from Guttram and Koch reaction, we can get aldehydes by using what? So by using benzene plus carbon monoxide and HCl. And for Itard reaction, which is the reagent? Chromyl chloride. So we can get it from toluene also. By what? From toluene, how to get it? From side chain chlorination, free radical substitution reaction, we call it as. Then you can get it from calcium salt of carboxylic acid also. Calcium salts of carboxylic acid. And this will give you both aldehydes and ketone. Gives you both aldehydes and ketones. So from calcium salts. Just a minute. Yes. So we can obtain it from. So we can obtain it from geminal dialide and vicinal dialytes. We can obtain from dialytes. So we can obtain by oxidation of alcohols. Oxidation of alcohols. So we can obtain by dehydrogenation of alcohol. Dehydrogenation of alcohol. Dehydrogenation of alcohol. All this method, what I've written on the right side, no, it gives both aldehydes and ketones. So it can give both aldehyde and ketone.
Excuse me, sir.
Whereas this reaction, no, these reactions provide only aldehydes. Yeah, tell me, any doubt?
The calcium salt of carboxylic experiments.
That I'll tell you, I'll show you there. Say, for example, if you take a salt of a formic acid, this is a formic acid, no?
Yes, sir.
And what is the calcium salt? SCOO twice Ca. Calcium formate.
Yes, sir.
And this one, if I subject it to dry distillation, we call it as eating without water, dry distillation. It breaks away. How it breaks, I'll show you it like this. Here on the version. What is SCO twice Ca? I'll write it down. SCOO. O. I will write once again. SCOO and Ca. And when you break it, when you subject it to distillation, okay, what will happen? This Ca combines with CO plus O to form what? Calcium carbonate. What is remaining? So what is remaining is H and CHO. What is H and CHO? Aldehyde.
Aldehyde. Yes, sir.
Got it?
Yes, sir.
So this is from calcium salt. This is from calcium salts. I'll remove it. Okay. So that I want to write the chart. Oh, sorry. Yes. I want to continue with this chart. So these are all the methods of obtaining both aldehydes. What I've written on right side is both aldehyde and ketone. What I've written on left side is only aldehyde. So how to get it by ketone? We can get ketone by what? Treadle-Craft isolation. So we can obtain it from Treadle-Craft isolation. You take a benzene and treat it with what? Acetyl chloride. We end up getting ketone. So we can obtain it from cyanide also. From cyanide also we can get a ketone. So from alkali we can get a ketone by treating with what? R2CD, dialkyl cadmium we call it as. Okay. We can also get it from Fry's rearrangement of a phenyl esters. Fry's rearrangement. So we can get ketones. All these methods, no, what I mentioned here, these are meant only for ketones.
Excuse me, sir.
Yeah.
Sorry to trouble again. That fries a rearrangement.
That is I told you, phenyl esters. I'll show you. Now you got this one?
Yes, sir.
Yeah, okay, I'll tell you. This RCN is by treating with RMGX. RMGX. You can, if you use SCN, look at here. If you use SCN and RMGX, you get RDX. But if you use RCN, alkyl cyanide, and a Grignard reagent, you get ketones. Okay. Now what I will do, I will go for next one. Shall I remove this chart, all of you?
Yes, sir.
You take a screenshot, but then you can save it. I'll remove it. I'll take one more chart. I will show you the reaction. I'll take a chalk piece, white one. Okay, you are asking for Fry's rearrangement, no? So what is this Fry's rearrangement? Means phenyl esters you have to take. And rearrangement of phenyl
Excuse me,
esters
sir.
also gives you ketone.
So there's a question, sir.
Yeah.
Sir, by Sonia, she's asking from acid chloride we get ketone, sir.
Yeah. I'll show you. I'll show you here. Both I'll show you.
Okay.
From acyl chloride also we can get ketones. What is acyl chloride? RCOCl. by treating with R2CD. Dialkyl cadmium. First, I will take questions from Anikesh from RBI, I think.
Okay, sir.
What is phenol OH? She's there on the line.
Yes, sir.
This is a phenol, no RBI.
Yes, sir.
And I will remove the H. Okay. What is ester? For ester, you have to put C double bond O CH3. Is it not?
Yes, sir.
CO linkage means ester. Is it not?
Yes, sir.
And here one H is there. Understood. And what will happen now, Arbia? I think you got it, I think.
Yes, sir. Now ketone with CH3.
H will go here, is it not?
Yes, sir.
It becomes OH,
Yes, ketone.
and that place is taken by COC. And this is nothing but what? Acetophenone. Acetophenone, where at second carbon atom we are having a OH. So 2-hydroxy acetophenone. And any compound having a general formula RCOCH3, RCOR is called as what?
Ketone.
Ketone.
Yes, sir.
Now I come to Sonia. Sonia, you asking about acyl chloride, no?
Yes, sir.
Very simple. Look at it. What will happen? You take 2 molecules of acyl chloride. Then what will happen, Sonia, is that this cadmium will combine with this chlorine. How many chlorine is there? 2 chlorine is there. So become cadmium chloride. Plus what is remaining now? RCO. How many RCO? 2 molecules.
2 molecules.
And R2 is there. That you write R here. And what is the formula? RCOR1. What is RCOR1? Ketone.
Yes, sir.
That's it. That is how you get it.
Okay, sir. Thank
And
you.
you can practice it. You can practice. What I'll do is that I have made a chart like this for every chapter. You make a chart like this. You never miss not even a single point.
Yes, sir.
I made a chart. If possible, I will send it as a PDF by today or tomorrow. Okay.
Okay, sir.
I think Anikesh will be having your mail ready. Then we can send it.
Okay, sir.
Yeah, right. This is done. So we'll go ahead now. I will clear it. If you can take a screenshot, you can take it. So these are the few preparations of what I've given. Next, what we'll do, we'll go to, before we get into chemical property, we'll discuss a little bit about physical property. Without taking physical property, let's just see. Okay. No. So what are the physical property you're supposed to study? Anybody?
Solubility.
Very important. What are the 2 important things you tell me? First one important is boiling point. So boiling point and solubility. So what are the things we have to remember in boiling point? Very simple. Remember, boiling point is proportional to number of carbon atoms. Number of carbon atoms. Very simple. That's it. So it is proportional to size. Is proportional to molecular weight. More the size, more the molecular weight, more the boiling point. So it is proportional to number of force of attraction. Number of force of attraction. Number of force of attraction. So it is proportional to, inversely proportional to branching. So it is inversely proportional to branching side. Next. So solubility. Solubility depends on what? For one thing, remember, all organic compounds are soluble in organic solvent. What is organic solvent? The alcohol, the benzene, the hexane. So all organic compounds are soluble in organic solvent. But whether these aldehydes and ketones are soluble in water,
Lower
is it?
members of aldehyde and ketones are soluble in water.
Yes. What is lower member with less carbon atom? Sir, lower members are soluble. Why they're soluble?
Because of H bond.
Because of hydrogen bond with water. Anybody who forms a hydrogen bond with water is soluble. Sir, is soluble. But one thing remember, so solubility is proportional to hydrogen bond with water. Anybody who forms hydrogen bond with water is soluble. But this is solubility in water, I'm speaking. But the solubility is inversely proportional to number of carbon atom. More the carbon atom, lesser the solubility. Got it, all of you?
Yes, sir.
Okay, right. Next one. We will go to chemical property. So what are the chemical property we are supposed to study? We have to study about nucleophilic addition reactions. So we have to study about nucleophilic addition reaction. Then we have to study about reactivity order. Nucleophilic addition reaction means how many we have to study? Sir, 4 reactions only. Reaction with HCN, reaction with sodium bisulfite. Sir, reaction with alcohol. One more is there. Can you tell me? Anybody? You have to remember like that. Oh, sir, for Grignard reagent. These are the 4 nucleophilic addition reactions that you have to study. And most of the questions revolves around these nucleophilic addition reactions. Because in a nucleophilic addition reaction, previously carbon is sp2 hybridized. But after the addition reaction, this carbon gets converted into sp3 carbon atom. And among the nucleophilic reaction, aldehydes are always more reactive than ketone. Why, sir? Because aldehydes is having more positively charged carbon atom. Whereas in ketone, that electrophilicity of carbon atom is less, steric hindrance is more, and electrophilicity is less. So aldehydes are more reactive. So first you show me one reaction. I will show one reaction, then we can move on to it. I'll take color. Say I'll take acetaldehyde. So what will happen when acetaldehyde reacts with HCN? Hydrogen cyanide. And always remember, this is what I told you. This is the carbon atom having positive charge. If positive charge is more, that is more reactive. And oxygen is always having negative charge. And your cyanide is having negative charge. So it attacks positive carbon atom. To form what? Sir, CH3, CH, and CCN. And this becomes OH. This is called as acetaldehyde cyanohydrine. So this is acetaldehyde cyanohydrine. So acetaldehyde cyanohydrine. And like this, how many I told you? There are 4 compounds have been given in the textbook. Please remember HCN, sodium bisulfite, ROH, RMGX. Very important. Among these, which is more reactive? We say aldehyd is more reactive. Why aldehyd is more reactive, sir? If you observe this, I will take one example. If you observe here, this is called as carbonyl carbon atom. It is having a positive charge. But here, the positive charge on carbonyl carbon atom is more, whereas here, the positive charge is less. Why, sir? Because the CH3 group is an electron donating groups. They decrease the electrons positive charge on the carbonyl carbon. So more the positive charge, more the reactivity. More the reactivity. If you take formaldehyde, sir, formaldehyde is having more positive charge than acetaldehyde. So formaldehyde is more reactive. So formaldehyde is more reactive. Formaldehyde is more than acetaldehyde. Acetaldehyde is more than acetone. That is ketone. Next. So we go for nucleophilic addition reaction. What is nucleophilic addition reaction? Yeah, addition elimination reaction. How many reactions are there here? 7 reactions are there. Or you can also say reaction of ammonia and its derivative. We call it as reaction with ammonia and derivatives. Ammonia and derivatives. And it's very simple. It is always just a removal of water. Removal of water. Say, for example, in ammonia, when you remove 2 hydrogen atoms, you get what? NH. So the compound is imine. Say, for example, I will take all the 7, I will write it on right side. So first one is ammonia. So when it reacts with ammonia, what you get? You get imine. Like that, when it reacts with, sir, NH2OH, you get oximes. So when it reacts with hydrazine, you get hydrazone. If it reacts with ammonia, sir, amines, you get a skiff base. If it reacts with semicarbazide, NH2, NHCO, NH2, you get semicarbazone. Well, a rhyming words. It's almost like a rhyming words. Semicarbazone. If it reacts with a phenyl C6H5NH2, it gives a respect to phenyl hydrazone. Like that, if it reacts with 2,4-DNP, it gives you dinitrophenylhydrazine. So these are the 7 reactions you have to remember in nucleophilic addition elimination reaction. Make a note. Oh, here nucleophilic addition reaction, 4 you have to remember. Here 7 you have to remember. Like that. You need to know what are the things there in this particular chapter. Then reduction and oxidation, very important. When aldehyd is reduced, you get primary alcohol. When ketone is reduced, you get secondary alcohol. You can use different kind of a reducing agent. And there are some name reactions out there. What are the name reactions? Very important. So when aldehys and ketones are converted into hydrocarbons, when they convert into hydrocarbon by using zinc amalgam and HCl, we call it as a Clemenson's reduction. When they're converted into hydrocarbon, aldehydes and ketone converted into hydrocarbon by using hydrogen and KOH, we call it as Wolff-Kishner reduction. Then you should know a little bit about oxidation. When aldehyde is oxidized, we get carboxylic acid with the same number of carbon atoms. When ketone is oxidized, you get a carboxylic acid with a lesser number of carbon. And also remember, for aldehyde, you can use mild also. Whereas for ketone, you have to use strong oxygen agents. Very, very important this is. Next, this is much more important reaction, alloform reactions. Alloform reaction is also called as iodoform reaction. They're also called as iodoform reactions. What is iodoform reaction? Where you get CHI3 as a precipitate, yellow precipitate you get. So give us one reaction, very, very important. This is because this is applicable to all the three chapters. Which are the three chapters? It is applicable to alloalkanes, it is applicable to alcohols, it is applicable to aldehydes and ketones. So what is alloform reaction, iodoform reaction? Whenever an organic compound, any organic compound, reacts with iodine and alkali, we call it as. Alkali means it may be NaOH also, KOH also. You end up getting a CHI3, yellow precipitate. Plus, you get RCONA. Plus, you get NaI and H2. All these are not important. Just remember that iodoform. And who can give this iodoform reaction? If it is alcohol, any compound having general formula RCHOH, CH3, only these kind of compound can give iodoform reaction, where R may be carbon or hydrogen. Then, so what about aldehydes and ketones? Who can give this iodoform reaction? Any compound having a general formula RCOCH3, where R may be carbon or hydrogen. Only they can give this particular reaction. Only they can give iodoform reaction. Next one. So what is the aldol condensation? Aldehydes having alpha hydrogen atom. Alpha hydrogen atom combines with dilute NaOH, remember this one, to form an aldol. What is aldol? Compound containing both aldehyde as well as alcohol. If you heat it a little bit, what will happen? So they lose water and they become alpha beta unsaturated aldehyde. This is called as alpha, this is called as beta. So this is called as alpha beta unsaturated aldehyde. Next, we'll go to Cannizzaro reaction. What is Cannizzaro reaction? These are the reaction given by aldehydes having no alpha hydrogen, like formaldehyde or benzaldehyde. They all give this particular Cannizzaro reaction. And here you have to take here you have taken dilute NaOH for aldol. Here you have to take a concentrated alkali, NaOH, concentrated KOH. You can take it. Whenever Cannizzaro reaction takes place, you get alcohol plus salt of a carboxylic acid. That kind of reaction we call as a Cannizzaro reaction. Then one more point, ESR reaction. What is ESR, sir? Electrophilic substitution reaction. Whenever aldehyde like benzaldehyde undergoes ESR reaction, what is ESR reaction? For example, chlorination. in presence of ferric chloride. Means chlorine will be attached to benzene. Where they attach? Is it ortho? Is it at meta? Or is it at para? Always remember, benzaldehyde, CHO is a deactivating group. This is very, very important. Sir, CHO is a deactivating group. Means it reduces electron density on benzene. Then it is meta-directing, sir. Meta-directing. That means Cl will come and attach to meta position, sir. Means 3. So you get a metachlorobenzol. Always, all ESR reaction. Which are the ESR reaction? Nitration, sulfonation, Federcraft reactions, bromination. All these reaction you get only meta in case of aldehydes and ketones. These are all called as electrophilic substitution reactions. So you got the property of the aldehydes and ketones, all of you?
Yes, sir.
Now we will move on to same thing. I given the same thing, nothing else. Distinguishing test for aldehydes. So what is the test for distinction between aldehydes and ketones? So we can do Skiff reagent. Aldehyde gives you pink color, whereas ketone gives you no color. So we can do Fehling solution test and Tollens reagent test, which is given only by aldehydes and ketoaldehydes. Aldehyde gives red precipitate with Fehling solution, black precipitate with Tollens reagent, or zero mirror is formed. Whereas ketones will not react, sir. So ketones will not react. So this is very important. And if you take a sodium nitroprusside, here the deep red color remains as it is, whereas here it changes to orange color. But most of the examination, these 3 tests are covered. Next, we'll go to carboxylic acids. What is carboxylic acid? Any compound having a general formula RCOH, where R may be H also, alkyl also, or alkyl group also. And physical property, already I told you. Lower members are soluble, and solubility is inversely proportional to molecular mass, means number of carbon. And one more important point, boiling point is very high. Why, sir? It is having an intermolecular hydrogen bond. By forming intermolecular hydrogen bonding, they have a dimer. What is dimers? They're having a structure like this. RCOOH, no? If I take another RCOOH, so between them, there is a 2 hydrogen bond. So we call it as a dimers. And that's why they are having highest boiling point compared to aldehyde ketones or alcohols or ethers or hydrocarbons. And melting point of melting point of carboxylic acids, aromatic acids are higher than aliphatic acids. And if you take a boiling point, who is highest? Sir, carboxylic acid is highest. Then what? Alcohol. Alcohol is more than yado, sir, ethers. Ethers are more than, sir, hydrocarbons. Hydrocarbons. Why, sir? Because carboxylic acid is having 2 hydrogen bonds. Alcohol, sir, it is having only 1 hydrogen bond. Ether, sir, only dipole. It's not very strong force. Hydrocarbon, they have only van der Waals force, very weak. Van der Waals force, we call it as. So remember, in organic chemistry, carboxylic acids are having highest bond. Sir, how to prepare this particular carboxylic acids? We can prepare it by oxidation of alcohols. We can prepare it by, very important, this is very important, by, sir, hydrolysis of cyanide, we get carboxylic acid plus ammonia. These are amides. Sir, by hydrolysis of amides, we can get carboxylic acid. This is esters. So from hydrolysis of esters, we can get carboxylic acid. This we call as a carbonylation because we are adding CO to alkene. Then also we can get carboxylic acid. So from Grignard reagent, what is Grignard reagent? CH10GPR. We get adduct, which decomposes to give carboxylic acid. Sir, methyl ketones. What is methyl ketones? This is CH3 next to ketone. That's called as methyl ketone. So they give upon reaction with NaOI means iodoform reaction. I told you no. Na plus NaO. This one NaOH. Iodine plus NaOH. I told you about iodoform reaction. This is iodoform reaction. Where the iodoforms are? Here, CHI3. This is yellow precipitate. The yellow precipitates. So, little bit of chemical property, let us see. Carboxylic acid, mainly there is a two kinds of reaction, cleavage of OH group, okay, and cleavage of CO group. This is the two reaction. Say, for example, if you're having a CH3 COOH, this is a cleavage of CO group. So what will happen here? Here, this OH group is replaced by other groups. Like what, sir? For example, if you treat with alcohol, what will happen? The OH is replaced by OR. What do you get? Any compound having CO linkage is called as ester. Esterification, sir. When you treat with PCl3, so replaced by Cl to give RCOCl. PCl5 gives RCOCl. Thionyl chloride gives RCOCl. So reacts with ammonia. It is replaced by what? NH2. So we get amides. If you treat with P2O5, phosphorus pentoxide, dehydration takes place to form anhydride. What is anhydride? Removal of water. So all this reaction is due to cleavage of the CO group. And these are the reactions which involves cleavage of what? OH group. If it is like this, OH, this reaction due to cleavage of OH group. Reaction with sodium. Look at here. It replaces that H and becomes hydrogen. This reaction with sodium indicates that alcohol is acidic. Don't mistake me, it is not acid, it is acidic. So, always remember, this reaction shows that this particular carboxylic acid is acidic. Anybody who reacts with sodium is acidic. Is it reacts with NaOH? NaOH is a base. So, this reaction indicates that it is acid. Oh, carboxylic acid is acid. And with sodium bicarbonate and sodium carbonate, they liberate carbon dioxide. This reaction shows that it is not only acid, it is a strong acid. Strong acid. Very important. That is acidic nature of carboxylic acid. I think they are given. They are not given. Okay. Okay. Here it is given. Very, very important. That acidic nature. What is that? Acidity order. Carboxylic acid is more acidic than phenol and alcohol. Electron donating group decreases acidity, withdrawing group increases acidity. Yeah, Muskan, tell me.
Excuse me, sir.
Yeah, tell me.
So when we are asked to give a test between two organic compounds in the exam,
Yeah.
then can we do the color distinction test?
Yeah, you can do it. You can do it. And for the, especially for carboxylic acid, no.
Yes, sir.
Carboxylic acid, usually we do this test, sodium bicarbonate test. What will happen? When you do it in a test tube, large amount of carbon dioxide is liberated. We say Oh, vigorous reaction takes place with the liberation of carbon dioxide. Effervescence is obtained until the bubbles of CO2 will come. When the bubbles of CO2 will come, it indicates carboxylic acid. If you take a litmus paper, this stator turns into red. If you take a blue litmus paper, it turns into what? Red. Is it practical is over for you?
Yes, sir.
There you're doing it. Okay. First come to acidic nature, very important. So remember, in a carboxylic acid, is acidic in nature, is a strong acid, is stronger than phenol, stronger than alcohol. Alcohol is stronger than alkyne. So among carboxylic acid, what will happen if donating group is there? What is the donating group? Which is the donating group? CH3, OCH3, OH, NH2. These groups, if it is there, they decrease acidic nature. Usually examination, these are the group they give. Sir, if electron withdrawing group is there, means what? NO2, CN, chlorine, bromine, iodine, fluorine. If these groups are there, sir, they increase acidic nature. And one more thing you remember, there is something called as ortho effect here, where in carboxylic acid, any group at ortho position sir will increase the acidic nature. Will increase acidic nature. Please remember this. This is all about acidic nature of carboxylic acid. We will discuss all these things when we take questions. And the common test what we do, I told you, for carboxylic acid is sodium bicarbonate. We can do ferric chloride test also, where carboxylic acid gets a buff color precipitate. Phenol gets a violet color. Alcohols, no reaction. And then these are the few more reactions. Which are the few more reactions? So reactions involving COH group. What is the reaction, sir? Decarboxylation. What is that? You have to use soda lime. So what is soda lime? Mixture of NaOH and calcium oxide. It removes the carbon dioxide. That's what it's called as decarboxylation. You are left with RH. RH is called as, sir, hydrocarbon. So removal of CO2 is called as decarboxylation. Reaction of R group. What is that, sir? We call it as L-Vollard-Zelinsky reaction. What is that? Replacement of a alpha hydrogen by halogen, we call it. So this is functional group, and this carbon is a alpha carbon. And the hydrogen attached to is called as alpha hydrogen. And this alpha hydrogen is replaced by halogen, sir. And that reaction we call it as L-Vollard-Zelinsky reaction. And then these are ESR, sir, electrophilic substitution reaction. I already told you, bromination is a electrophilic substitution reaction. Here electrophile is Br plus. So Br plus can attack ortho, meta, or para position. So you want to know where it goes, sir? It goes to meta position. Why, sir? Simple. QH group is a deactivating group, and it is meta directing. You got it, all of you? Yes or no, all of you?
Vollard-Zelinsky reaction.
Yeah. Vollard-Zelinsky reaction is very simple. What is that, sir? Replacement of a alpha hydrogen by halogen. What is alpha hydrogen? Look at it. This is functional group. Next to that is alpha carbon. And hydrogen attached to alpha carbon is called as what? Alpha hydrogen. When you treat with red phosphorus and halogen, one hydrogen atom is replaced by what? One halogen. This kind of reaction we call as Yel-Wollard-Zelinsky reaction. Got it?
Okay, sir. Yes, sir.
Yeah, right. Now all the theory component is done. Now we'll go to questions. You know that one. In your part A, you get MCQ, no?
Yes, sir.
Now can you answer it?
Sir, option A.
Option A. I told you. These are calcium salt, no?
Acetone, sir.
Calcium salt will always gives you aldehyde or ketone. Aldehyde or ketone means this cannot be the answer. This cannot be the answer. Either second or fourth.
Acetone, sir.
Yeah, very good. Always remember. Look at here. If calcium formate is not there in the picture, if calcium formate is there, you always get aldehydes. No calcium formate. If calcium formate is not there in the picture, you always end up getting what? Ketone. Just this point, this 2 point is enough. So in this picture, means in this question, whether calcium formate is there?
No, sir.
Not there. Not there means it has to be ketone, sir. Ketone means only one option. So fourth is the answer. Got it? All of you?
Yes,
Let
sir.
it be any calcium salt. Let it be any calcium salt. This is a shortcut. Let it be any calcium salt, let him give. Very simple. In the picture, calcium format is there means it has to be aldehyde. In the question, if the calcium format is not there, that means it is a ketone. Over. Next one. Which of the following on eating with aqueous cleavage produces acetaldehyde? How to answer this? If you observe it, I told you.
Third option, sir.
Third option. Very
So
good.
option
Very.
4.
Option 4 cannot be. You know why? Because I told you about dialytes, remember? From dialytes, we can obtain aldehydes and ketone, is it not? But there are two kinds of dialytes. Which are those? Tell me. One is geminar,
And
other is
vicinal.
vicinal. What is vicinal? Where chlorine is halogen attached to
Adjacent.
adjacent carbonate.
Adjacent carbon.
What is geminal? Where halogen attached to same
Opposite.
carbonate. Is it not? If it is geminal, I told you, it is always a ketone. If it is vicinal, it is always a aldehyde. Or you can put it like this also. What is that? Look at here. Here, sir. Here is a vicinal dihalide. This is a vicinal dihalide. Here, this is also dihalide. What kind of dihalide this is? Terminal. So terminal dihalydes always gives you aldehydes. So non-terminal gives you? Non-terminal geminal dilate gives you? Always gives you ketone. Is it terminal or non-terminal? It is a terminal, sir. Here, the Cl2 is present on the last carbon atom or first carbon atom. Terminal it is. So if it is like this, CH3, Cl like this. If it is like this, then it gives a ketone. So please remember, terminal and non-terminal. Make a correction. Don't take vicinal. You take it as terminal dilate, non-terminal dilates. Got it, all of you?
Yes, sir.
So what should be the
Yes,
answer?
sir.
So third option. Fourth cannot be, because fourth is not halide, dihalide. It is an acetyl halide.
Yes, sir.
Next one. So look at here. So the Cl is replaced by OH, is it not? And I told you, two OH cannot attach to same carbon atom. So they lose water molecule and you get aldehyde. Over. Which of these will not give aldehyde?
Second one.
So second one.
Second one, Very good, very good. Which of the following will not give aldehyde? Especially will not give benzaldehyde. You know that this is a first one is a Gutterman-Koch reaction.
Yes, sir.
So it gives
Yes,
aldehyde. So this cannot be the option. And this is toluene reacts with
Itard
chromyl
reaction.
chloride to give
Without reaction.
benzaldehyde. Itard reaction. So this is also not the option. This is
Rosen.
Rosenman reduction. So this is not the option. What is the option then? Second.
Rosen.
Very good, very good. Next one. Formaldehyde can be distinguished from acetaldehyde by the use of what? Imagine you are having a formaldehyde. This is formaldehyde. And you are having acetaldehyde. You are doing this test.
Haloform with
Yes, you got it. So skip reagent. Both are aldehyde. No, both gives pink color. Filling solution, both gives red color. Tolerance reagent, both gives silver mirror. So what is the answer? Sir, this is iodoform reaction, sir. What is iodoform? Sir, we get CHA3.
at least one CH3 group.
And who can give this? Only those compounds which are having a methyl carbonyl. What is methyl carbonyl? Sir, CO pakka CH3 irbek, sir. HCH brenada. What is HCHO? HCOH. ಇದನ್ನ CH3 CHO brand. CH3 and C double bond OH. And look at here. Compare it. Next to CO, there should be CH3. Say where? Here it is not there. So this is not, will not give. Will no reaction. Whereas, yes, sir, here next to CO, there is a CH3. It gives a yellow precipitate of iodophorone. Answer is iodine. Take a screenshot. Take a screenshot if you want. Next, Clemenson's reduction of ketone is carried out in terms of
So option 3.
option 3, zinc amalgam. Yes, here. Clemenson's reduction, we call it as, okay, here by mistake he has given sodium, you make it as zinc. Take a screenshot. Cannizzarose reaction is not given by you know that Cannizzarose reaction is not given by the aldehyde having no alpha hydrogen atom.
Sir, option 4.
Hey, option 4 does not have alpha hydrogen. Here, no alpha hydrogen. No alpha hydrogen means they give this reaction. Here,
Option 3.
no alpha hydrogen, they give. No alpha hydrogen, they give. This is a functional group. So this is alpha.
CH3.
So it is having alpha. That means it will not give. Take a screenshot. Silo mirror test is given by which of the following compound?
Sir, acetaldehyde.
Aldehydes will give tolerance reagent and Pelling solution. Can you tell me how they give silo mirror? Anybody? How they give silo mirror?
Sir, aldehyde is treated with tolerance reagent silver nitride
What will
with
happen?
OH. Then it gives RCOO minus and silver mirror.
Very simple. You can put it like this. So acetaldehyde reduces Ag plus, and Ag plus becomes what? Ag. And that Ag get deposited on the inner side of the test tube. And from outside, it looks like a silver mirror. Next one. Increasing order of rate of addition of HCN to a aldehyde. What is the rate? Aldehyde and T2.
Sir, is it third option?
Third option. No, I told you. Always remember, first thing. Aldehyde is more reactive than ketone. Where is the aldehyde? A is the aldehyde. So this is more reactive.
It will be last. A.
More reactive. Means A is more than everybody. Then what is pH? pH is benzene, C6H5. More the benzene ring, more the steric endurance. So here there are more pH, sir. So this is less. Sir, here only one pH is there. Here no pH. So A is more than B. B is more than C. C is more than D. This is called as what? Decreasing order. He is asking what?
Increasing order.
Increasing order. Then what you have to do? You have to write it ulta. D is less than C, C is less than B, B is less than A. Which is the option?
First one.
First option, sir. Take a screenshot. Which one of the following undergoes reaction with 50% sodium hydroxide solution to give corresponding alcohol and acid? What is the reaction is known as?
Benzaldehyde.
Canizerose reaction. Very good. And canizerose reaction is given by aldehyde having no alpha hydrogen atom.
Yes, sir.
What is canizerose reaction? Can anybody tell me?
Sir, when aldehyde with no alpha hydrogen is treated with NaOH,
Which
it
NaOH?
is
Concentrated alkali. NaOH, not only NaOH, you can take KOH also.
yes, sir.
Any alkali. What is alkali? Anybody? Base soluble in water. Base soluble in water is called as alkali. So if alpha hydrogen, what is the option then? Sir, butanol.
B. Benzaldehyde.
Phenol will not give. Benzoic acid will not give. So aldehyde will give. So these two options.
Sir, how we found Cannizzaro reaction, sir?
This is no, he says, look at here. He says what? You get alcohol. So here is the alcohol. He says acid. Here is the acid. Got it? No? Got it?
Yes, sir.
Yes.
Like this. You ask me anything, anything you ask me, no problem. Even if it is silly also, don't mind. So option should be either 1 or 2. What is the option then?
Second
Benzaldehyde.
one.
Second one. Very good. Very good. Very good. That's it. Which one of the following gives yellow precipitate with iodine and NaOH solution?
First one, sir.
First one, sir.
What is this reaction is known as? Iodoform reaction.
Iodoform.
Very good. Very good. Iodoform reaction. What is the condition? Sir, then you should have a RCOCH3, sir. So alcohol cannot be, sir. So there are only 2 options. Sir, here is the ketone. But next to that is a benzene. So not possible. Only option is 1. Very good. Fantastic. You are already getting it. The liquid was mixed with ethanol and drop of concentrated sulfuric acid was added. A compound of fruity smell was formed. The liquid was.
So option 3.
Option 3. Very good. Very good. What is this process is known as? Esterification.
Esterification.
What is esterification? Sir, carboxylic acid should react with alcohol to form what? Ester. What is ester? R. So if you take it 1, R1, the OH, the OH of carboxy group react with H to form water. Then what will happen? RCO combines with O and R1. Compound having CO linkage is called as ester. This is ester, sir. So he is asking, alcohol is there, that is ethanol. Sulfuric acid is there, So what is required? RCOH is required, and that should be carboxylic acid. Very good. What you told is right. Third option, sir. Among the following acid, which has the lowest pKa value? What is pKa? What is pKa? Oh, you have to remember. So strength of acid can be measured by Ka. What is Ka? Dissociation constant of acid. Constant of acid, sir.
The third one.
Here, no. If K is more, or you can take it as pKa. If pKa is less, that means it is a strong acid. Stronger acid. Is a saying lowest pKa means strong acid. This is the strong acid among all these things. So these electron donating groups, and you know that electron donating group decreases acidic nature. In all this, you're having a CH2 groups. So this cannot be answered. Here, acidic nature is less. Acidic nature less means it is having more pKa. More pKa. He's asking what? Lowest pKa means it is a strong acid, sir. Which is the strong acid? STOH is the strong acid. Very good. The answer. Already I told you. We in the preparation of carboxylic acid have discussed. When you take carbon dioxide and CH2MgBr, what will happen? Carbon dioxide is nothing but C double bond O, C double bond. And to that, when you add CH3MgBr, I told you carbon is having positive charge. So CH3 will attack it. To form what? Sir, it becomes a C double bond O, CH3. Then what will happen? The O combines with MgBr. Then this break it with water. What is water? H plus and OH plus. This bond will break. Then what do you get? Sir, CH3, C double bond O, and the OH combines to form acid plus you get hydroxy magnesium bromide. So what is this compound? So it is called as acetic acid. What is the option? First option. Let us take some questions. Okay, this is all MCQ, no? Assertion and reasoning. Because in MCQ, all the questions are not MCQ. Few of them are assertion and reasoning also. What will be the option? Can you tell me? Is it the first statement right or wrong? I told you, solubility always decreases with number of carbon atom. It's inversely proportional to, sir, number of carbon. So A is right, sir. Then what is the answer? Is it a alkyl groups are electron releasing group? Yes, alkyl are electron releasing groups. Correct, sir. And that's why hydrophobicity increases. But this is not the right explanation. It is the right only, but not a right explanation for A. So option is 2. This is all this we have done now. We'll take. Illustrate the following name reaction with example. This is very short answers. What is Clemenson's reduction?
Aldehyde or ketone reacted with zinc amalgam and HCl.
Yes. Yes. Very simple. First, how to remember. Sir, aldehyde is reduced to what? Hydrocarbon. Aldehyde is reduced to hydrocarbon. By using what? Zinc amalgam and HCl. Very good. Remember like this. Then write one example. Any one example. Sir, CH3CH4. I subjected to reduction. What reduction? Addition of nascent hydrogen. And what do you get? This hydrogen is added to this one, sir.
Ethane.
How many carbon is there? Sir, 2 carbon is there. Then I get hydrocarbon having 2 carbons, sir. CH3 plus CH3. I get ethane. What will happen to oxygen? Sir, oxygen becomes H2O. Yes. Look at here, how many papers it has appeared. And all reduction, no? Name reaction, don't leave it. All name reactions are important. In this reduction only, what are the name reaction? Rosenman reduction, Stephen's reduction, Clemenson's reduction, Wolff-Kishner reduction. Don't leave it. Very easy to remember all these things. Next question. Illustrate decarboxylation with example. When you say decarboxylation, remember soda lime. What is soda lime?
NaOH,
And that's it. What is their job? Sir, to remove carbon dioxide.
carbon dioxide.
That's it, over. And you give an example. What is the example? Take CH3COH. Then just write NaOH and CaO on the arrow mark. So what will happen? First, the H and the OH combine to form water. First, you get sodium salt. Then what will happen? Again, one more NaOH will react. This time, Na plus Na become, sir, Na2CO3. This CO is also written. So what is remaining? H and CH is there. H and CH is nothing but CH4. Like this, you have to write. Draw the structure of X2 in 4-winoic acid. That means what are the function group present? Double bond,
Carboxylic acid.
triple bond, and COH. What is the first priority? Who is having first priority?
Carboxylic acid. Sir.
How many carbon atom? 6 carbon. Right, 6 carbon. 1, 2, 3, 4, 5, 6. And write COH. So this is having first priority. 1. 2. Double bond is there. Write double bond. 3, 4. Triple bond is there. Over. That's it. Fill up the valency of carbon. What is the valency of carbon? 4. Sir, already 4 bonds are there. Here, 4 bonds are there. Here, 3 bond is there. Right, H. 3 bond, H. Over. This is the compound. What is the APC name of the given compound?
Pent-2-enoic acid.
How many carbon atoms are there?
5.
The 1. 5 they are given. Pent, you write. Pent, sir.
2-enoic.
Pent. Double bond is there. Where? At 2. Right. In.
acid.
So E should be replaced by oic acid. Pentanoic acid.
Sir, here aldehyde group is present. How we can write oic acid?
Right. I thought you are right. You are right.
Aldehyde. Yes.
Yeah, it's an aldehyde. No. Then we have to write pent. Okay. 2 in R. 12. I just cite as a carboxylic acid. Got it? Right? Is it right now?
Yes, sir.
Yeah, right. What is the name of this compound? Select a longest carbon chain.
Bute.
Bute.
2-chloro.
Single bond is there. So it's the butane.
2-chloro. 3,3 meth.
Okay, if you come from this side, it is 2-chloro, is it not? 1, 2, 3, 4.
Alphabetic order.
If you come from this side, it is 1,
2.
3, 4. Which one? From where I have to come? Whether I have to come from right side or if I have to come from left side. Then
Sir, right side.
you have to follow something called as lowest sum rule.
Left to right.
What is lowest sum rule? Just add the locants. Locant means where the position is added. Chlorine is added at second, sir. If you come from right side. Right, second. Then methyl group is at third. 2 plus 3 plus 3. How much? What is the number? Total number?
9.
8.
Hey, 3 plus 3. 6 plus 2, 8.
9. 8.
So let us go from left side. Sir, at methyl group is at 2 place. 2 plus 2. And chlorine is at third place.
7.
How much it is?
7.
Which is lowest sum?
Left to right.
Left to right. Sir, we should not take right. Got it?
Yes, sir.
Yes. Then you number, you write it according to alphabetical order. Who come first?
3
Chlorine.
chloro. 2,2.
So it's a 3,
3 chloro.
3 chloro,
2,2
2, 2
meth.
dimethyl butane. Got it, all of you?
Yes, sir.
Yes, sir.
Yes. Now I think there's a small break now for you people.
Yeah, sir. It's a break from 5:50 till 6:05. So we'll
5:50,
join back
please.
again at 6:05, sir.
Yeah, right. I think 5 minutes I'm late.
It's okay, sir.
No problem. Okay, then no problem. Give them a students bit break.
Yeah,
start
they'll
from
have a
6:10.
refreshment and then they'll come back, sir.
Yeah, let them. We'll start by 6:10 then.
Okay, sir. Fine,
Okay.
sir. So students, please have your break. You have a break till 6:05, 6:10. Extra you have extra 5 minutes. Okay.
Thank you, sir.
And do you have any
And
doubts
Anikesh?
regarding? Yes, sir.
No need to log out for me, no? I can.
Yes, sir. You can be in the session only, sir. No need
Okay,
to
right.
log out, sir.
Okay.
Yeah, students. So if you have any doubts, anything regarding session, you can just text me now. Yes, Serbia, I'll ask sir to share that sample papers. Don't worry, I'll share it in the group. Anything else?
No, sir. Thank you, sir.
Yeah, it's okay. You can just unmute yourself and you can ask me any doubts, anything related to your studies. If you're facing any difficulties regarding your studies or anything, you can ask me now. So, I'm a good counselor too. I can just motivate you. I can just resolve your questions too, related to your studies, related to your mindsets. Anything you can ask me. I can help you out with those things also. So, hello?
Shall we start?
Yes, sir, we could start now, sir.
So what is the next question? Draw the structure of paramethyl benzaldehyde. So what is benzaldehyde? You know that one, no? CHO. Para means this is 1 means this is 4. Position is 4. Here we are having CH3. What is 3-methyl butanol? But means how many carbon atom? 1, 2, 3, 4. 3-methyl means at third carbon atom, you're having CH3. At first carbon atom, you're having aldehyde. 1, 2, 3, 4. Then fill up the valency of carbon. Sir, CH3, CH, CH2. So write the reagent required in the following reaction. What is the reagent required here?
Sir, we can use PCC or KMNO4.
So what is happening here? Sir, here alcohol is converted into what? Aldehyde. So you can use controlled oxygen agent like PCC or CrO3 you can use. Arrange the following compound in the increasing order of their boiling point.
Sir, first it will be CH3CH2OH.
Why?
So alcohol has the maximum, means they have the,
Hydrogen bond.
yes, sir.
That's why they're having more boiling point. So this is the first one.
Then
Then
CHO.
CH3CHO
Then CH3CH2CH3.
Yes, this is at last. This hydrocarbon, no, this should come at last. Among aldehyde
Yes.
and ether, who is having more boiling point?
Sir, aldehyde.
Aldehydes are having more boiling point. He says increasing order. What is increasing order? Lowest to
Highest.
highest. Always remember this one. Increasing order means the lowest to highest. Lowest to highest. Who is lowest? Hydrocarbon is lowest. That means E should come first. CH3, CH2, CH3. You write it like this. Lesser than, sir, ether. Lesser than aldehyde. Sir, lesser than alcohol. Like that, you write. This is increasing order. Next one. Arrange the following compound in the increasing order of their acidic reactivity towards nucleophilic addition reaction. I told you, whenever towards nucleophilic addition reaction, I told you, carbonyl carbon should have a more positive charge. Should have more positive charge. Means electrophilicity should be more. And I already told you, aldehyde is always more reactive than ketones. So which is the aldehyde? So CH3 is aldehyde, whereas these are ketones. So increasing order means, sir, CH3CHO is more reactive. Everything else is less. And here, benzene ring is there. When there is a benzene ring, steric hindrance is more. So that is less reactive. So that should come first, sir. Then should come acetone. Acetone. Next one. All this you can take a screenshot. Predict the product of the following.
So H2O will be removed and
Very good.
instead of double bond, we will write
Propane.
NNH2.
Propane.
Yeah. Not propane. You write it like that only. CH3. C double bond, write it like that only. What is remaining? NNH2.
Yes, sir.
NNH2. Like this you have to write. This is hydrazine. NH2 is a hydrazine. And this compound is hydrazone. The name should end with hydrazone. Hydrazone. What is this? So this is acetone. So this compound is acetone, hydrazone, hydrazone.
Sir, I have a doubt.
Yeah.
So we will leave NNH2 like this only, or we will simplify it more.
No. This is the end of the molecule. We will
Okay,
leave
sir.
like this only. But you have to show that you remove what? You remove water. Either you can show it like this, either you can also at the end you can write it as this two. And what is the compound we get it here? What is the reagent? So ketone is converted into what? Secondary alcohol.
KMNO4.
Oh, KMNO4 is a strong oxidation agent. What will happen? Then this also becomes carboxylic acid. We have to use controlled oxidizing agents. PCC. Or Jones reagent. Or simply chromium oxide in acetic anhydride. These are all the controlled oxidation agent. They stop the reaction at aldehydes or ketones. Write the structure of a major product in the following reaction. Like this, they will give you. You have to fill it up. If you look at this reaction, hydrazine and glycol means.
Propane it will be sodium.
Yeah, it should be Wolff-Kishner reduction. So it is a Wolff-Kishner reduction. What is a Wolff-Kishner reduction? Sir, aldehydes are converted into hydrocarbon. Hydrocarbon. And just very simple. See, in this molecule, how many carbon is there? So 3 carbon is there. Very simple. Then you end up getting hydrocarbon having 3 carbon. That is propane. But he is asking structure of the major product. Over. That is enough. Propane.
Sir, but hydrazine is given, so why we didn't did that reaction? Removal of
No. Well, look at the question. What is the
major product?
But how this reaction takes place now, I will tell you. It happens like this. First, it reacts with hydrazine. H2 will combine with O, no? To form what? H2O. What do you get? CH3, CH2, C, double bond, N, NH2, CH, double bond, NH. Is it not?
Yes, sir.
Then what you do? You take glycol, second step. Glycol you have to take. So what will happen with glycol? The molecule will break. How it breaks? NN becomes N2, nitrogen gas. Then what is remaining? No? CH3, CH2 dash H plus H2. It becomes what? CH3. But he is not asking all these things. Got it? He is not asking all these things. What is asking? Major product. Just you have to write this much only. Got it?
Yes, sir.
And this one. Look at this
Cani-Zaro
molecule.
reaction.
Consonance. What is this reaction? Anybody?
Cani-Zaro.
Very good, very good. Because it is not having alpha hydrogen atom. No alpha hydrogen. So it gives you Cani-Zaro reaction. And in Cani-Zaro reaction, what you get? Alcohol
and
plus
salt of carboxylic acid.
salt of carboxylic acid. Very good. Salt of carboxylic acid. Benzaldehyde can be obtained from benzyl chloride. Write the reaction for obtaining benzyl chloride and then benzaldehyde from it. It all starts with toluene, no? I told you. Toluene undergoes side chain reaction with chlorine in presence of sunlight. What will happen? The hydrogen gets replaced and you get CHCl2. This is called as benzol. Benzyl chloride. And when this reaction reacts with aqueous KOH, two molecules of KOH, you get 2 KCl. And you end up getting 2 OH attached to CH. And I told you in chemistry, 2 OH group cannot attach to same carbon atom. Is unstable. The H and OH combine to form water. Now what is remaining? So benzene.
Benzaldehyde.
Yes, benzene with CHO. That is benzaldehyde. This is the reaction. Name the electrophile produced in the reaction of benzene with benzyl chloride in the presence of anhydrous aluminum chloride.
Caterman coach, sir.
Hmm?
Coach.
Hey, no. This is Friedel-Crafts acylation. Friedel-Crafts acylation. What is a Friedel-Crafts acylation? Anybody? Aromatic compound
So CH3C double bond is
reacts with acyl halide to form what? Acyl aryl compound. This kind of reaction is known as Friedel-Crafts acylation. What is the aromatic compound here? Benzene, he says. What is the acyl halide? He only says benzyl chloride. What is benzyl chloride? COCl in presence of aluminum chloride. What will happen here? Here one H will be there. The H and Cl will combine to form what? HCl. What is remaining now? Sir, benzene without H. And there is a CO and the CO group will bind the two benzene ring together. And this is called as benzophenone. Like acetophenone, it is called as benzophenone. But the question is not that one. What is the question? Name the electrophile. So reaction name you are given. Name of the reaction is Treadle-Craft acylation. What is the electrophile? It's a ESR reaction. Electrophilic substitution reaction. That means electrophile will be there. Which is the electrophile? Always electrophile is generated by AlCl3, which reacts with benzene, benzyl chloride to form what? AlCl4 minus. And what is remaining? This part is remaining. What is that? T6H5CO plus. This group is called as benzyl group. Benzyl group is present. So benzyl is the electrophile. What is electrophile? Species deficient in electron. That means electron is less. So they usually have a what charge? Per charge there. Take the product of the following reaction.
Propane.
Already this reaction we have done now. What is this reaction?
Wolf-Fischer
Oh.
reduction.
Wolff-Fischer reduction. What do you get? Sir, we get hydrocarbon here.
Hydrocarbon.
That depends on how many carbon you are having. How many carbon you are having here? 3 carbon. So you end up getting what? Propane. Propane you get, sir. Then here what do you get? What is this NaOH and iodine?
Iodoform.
Iodoform reaction. Very good. So one product is iodoform. What other product is? Salt of carboxylic
Sodium.
acid. CH3 will give you CHI3. This part is there, no? This gives you salt. What salt? C6H5 COO Na. Plus, what else you get? Plus NaI. So plus water you get. Iodoform reaction. Iodoform reaction. Please take a screenshot. How will you carry out the following conversion? Ethanol to acetone. How will you do it?
Sir, we will use PCC.
PCC. Can you do it? Do it. You cannot do it. Why? Because ethanol is a primary alcohol. And primary alcohol gives you aldehyde, not ketones. What you have to do then? You observe it. What to observe, sir? The number of carbon. Ethanol is having how many carbon? 2 carbon. Acetone is having 3 carbon. What is acetone? CH3COCH3. Is it not? Then how to convert this 2 carbon into 3 carbon? First, what we'll do, we'll take ethanol. What is ethanol? CH3
CH3 CH2OH.
OH, and then convert with PCl. What do you get? OH will be replaced by Cl, you get POCl3 minus HCl. This you treat with KCl. What do you get? CH3, CH2Cl. Now one carbon will increase now. This I will reduce it. If I reduce it, means addition of hydrogen. What I get? CH3, CH2, CH2, NH2 it becomes. Amine, primary amine. And I know that primary amine can also be converted into alcohol by treating with HNO2 nitrous acid. It becomes what? Alcohols are CH3, CH2OH. Again, I got alcohol. CH3, CH2. Then what you do to this? You add PCl5. When you add PCl5, again, same like this. OH will be replaced by Cl. CH3, CH2, CH2Cl. Then you treat with alcoholic KOH now. Alcoholic KOH. You know what is the reaction? Beta, elimination. What will happen? Sir, you get CH3, CH double bond CH2. You get propane. And now it is very interesting. Propane. This we do hydration. What is hydration? Addition of H plus and OH minus. This follows which rule? Markovnikov rule. What is Markovnikov rule? Negative part attaches to that carbon having a less hydrogen. CH3CH, OH, CH2. Now it has become secondary alcohol, sir. Yes, now you do oxidation. When secondary alcohol undergoes oxidation, it gives you what? Ketone. You get acetone. Take a screenshot. This is not a short answer, this is a long answer. Give the simple chemical test to distinguish between pentane 2-on and pentane 3-on. Which test you can give? What is pentane 2-on and 3-on?
Pyroform, sir.
Very good, very good. You can take iodoform test. Why, sir? Iodoform test is given by compound having RCOCH3 group, sir. Let us write the structure, two structures. Pentane 2-on, CH3, CH2, COCH2, CH3. This is 2-on. Oh, sorry, 3-on. To CH3. What is this? So this is 3-pentanol. Because at third carbon atom, you're having ketone. I'll write 2 ketone. CH3CO. Sir, CH2, CH2, CH3. This is 2-pentanol. And 2-pentanol is having a CO group next to CH3. So it will give iodoform test, sir. It will give. But here, after CO, there is no CH3 on both the side. So it will not give. Not will give iodoform. Because next to CO, sir, next to CO, I want CH3 group. Methyl carbonyl. So that is not there here, 2-pentanol. So 2-pentanol will not give. 3-pentanol will not give. 2-pentanol will give. So we can use iodoform. And iodoform always gives you yellow precipitate. So easily when you do it in a test tube, we can see the yellow precipitate and you can tell, oh, 2-pentanone is present. How to separate ethanol and propanol?
Iodoform.
Iodoform.
Iodoform. Yes, very good. Very good. Next one. Complete the following reactions.
Canizaro.
Very good. Canizarous reaction. Concentrated alkali means and no alpha hydrogen atom. Is it not?
Yes, sir.
So
Alpha
Canizarous reaction. Very good. This one. HNO3 and sulfuric acid means it is a nitration.
nitration NO2.
Nitration means it is a ESR reaction. Which is the electrophile here? Sir, NO2 plus is the electrophile. NO2 plus is the electrophile. So NO2 plus will attack this benzaldehyde.
Meta
What
and
product you
para
get?
position.
Ortho and?
Ortho and
Para.
para.
No. CHO is a deactivating
Deactivating
group.
group. Yes, sir.
That means it is a
Meta.
meta directing. Say this is the aldehyde. Meta means 1, 2. At 3 you get NO.
So we'll get another product too.
No, you will not get other product. Other product is what? Water, subproduct.
Fourth
This is a major
position.
product. Because here no. At one H is there, no.
Yeah.
H will combine with OH to form what? Water.
Okay, sir.
Water. Why, sir? How can you tell like this? Exactly speaking, this takes place like this. When it reacts with HNO3, no. Always we write sulfuric acid on the arrow mark because it is regenerated, okay?
Yes, sir.
And HNO3 can be written as OH and NO2, no?
Yes, sir.
And you already written NO2 on benzaldehyde. Here, one H is there, and H was replaced by NO2. And the H and this OH come into form water.
Okay, sir.
Next one. The organic compound with a molecular formula C9H10O forms a 2,4-DNP derivative, reduces Tollens reagent and undergo Canizarous reaction. On vigorous oxidation, it gives 1,2 benzene dicarboxylic acid. Identify the compound.
Sir, it's an aldehyde
Very simple. Already. Why? Because, sir,
because it goes through
reacts
Tollens
with
reagent
DNP derivative.
and it reduces Tollens
When it says
reagent to
2,4-DNP, it may be aldehyde also.
ketone too.
But when you say it reduces Tollens reagent, it is only aldehyde. And then he says undergo Canizarous reaction. No alpha hydrogen atom. And then you say benzene. Means there should be benzene. When it undergoes Canizarous reaction, it has to be benzaldehyde. On vigorous oxidation, you say 1,2-benzene dicarboxylic acid is formed. 1,2-benzene dicarboxylic acid. That means 1,2 means what? Second position. There should be CH3. Let me see it. This is the compound. Got it?
Yes, sir.
Next one. What is the answer? This is a combination of both basic concepts of chemistry as well as your aldehydes. He says does not reduce Tollens rate. That means what? ketones. So it has to be ketone. But forms addition compound with sodium hydrogen sulfide and gives a iodoform test. What may be the compound? How to do that? Anybody? How to do that? First, what you have to do, take elements. Which are the elements? Carbon, hydrogen, oxygen. Then write the percentage. What is the percentage they are given?
69.77.
So 69.77. And here, sir, hydrogen is 63%. Sorry, 11.63. 60. And oxygen is, rest is oxygen. How much remaining then? 69.7. 73 is the 10, no? 10 means 18.60. So we got the percentage of all elements. Then what we have to do? Then take its molecular weight or atomic weight. What is atomic weight? Of carbon is 12. One oxygen is how much?
16.
16. Then you know how to calculate moles. What is mole? Mass by molecular weight. What is the mass? 69 by 77 by 12. 11.63 by 1. 18.60 by 16. It almost comes to 1 only. This is 1. This is 11.63. And this how much it comes? 12 5s, no?
34 point.
Huh? 5 point? Around 5 point
8,
something.
sir.
It comes.
5.8.
Okay. Okay, let us take it as 5. So if I can take it as round it off, 5, 11, 1, no? Is it not?
Yes,
Yes,
sir.
sir.
5, 11, 1. Then we can empirical formula is then C5 H11 O. What is the empirical formula weight?
5
Add up
into
all these.
12
12
5
5
into
60.
12
plus
Yes,
10
very
into
good.
1.
Plus 11 into
And
1
1
plus
plus 16.
16. How much it comes?
87.
8?
86.
7.
87.
87. Okay. 87. Okay. Then we'll take it like N is equal to what? Molecular formula is equal to N into empirical formula. What is N here? We don't know, sir. That we will calculate. N is equal to empirical formula weight by molecular weight. Empirical formula weight is how much? Sir, 87. Molecular weight is how much? He has already given. How much he has given?
86.
86. Almost is equal to 1, no?
1. Yes, sir.
That means it is almost same. C5H11 1. Whoa, is it not?
Mm.
C5 means it is having how many carbon atoms? 5. 1, 2, 3, 4, 5. And look at here. He says an oxidation gives propanoic acid and ethanoic acid. That means the ketone should be present on the second carbon atom. Third carbon. Second one. Because it gives iodoform test, no? It gives iodoform test. So it should be here. Then this should be CH3, CH2, CH2. Then what will happen when you do oxidation? This 2 carbon becomes ethanoic acid. This 3 carbon becomes propanoic acid. Is it right? Got it, all of you?
Yes, sir.
Next one. These are long answer questions like A, B, and C are 3 non-cyclic functional isomers. Please read it and tell me what may be the answer.
B is a ketone, we can say, sir.
Just a minute. Here, no. There's a small thing you have to remember. When we do this, we get 5.86. No, here. Just check it out. 69.77 by 12 is how much? How much you got?
Yes, sir, 5.8.
Then what we have to do is that in this lowest number is what? 1, no?
1.
And we have to divide it by 1.
Yes, sir.
Exactly speaking, this comes to around 1.16. Is it not? Let's check it out. 18.60 by 116. 16, how much it is? 16 ones are 16, no.
Yes, sir. Correct. 1.16.
Then when you divide all these things, this becomes not 11, this becomes 10. We have to divide everything by lowest number. Got it?
Yes, sir.
What you have to do is that 5.86 by 1.16. Then 11 by 1.16.
Yes, sir.
1.16 by 1.16. This becomes 1. This becomes how much? 10. This becomes 5. So this not 11. This becomes 10. 10 means it becomes exactly 86. It is 86 by 86. 1. It is not C5H11. This is C5H10. Why I have told you no? Look at our structure. How many carbon is there?
10 hydrogens.
5 carbon. How many hydrogen? 10 hydrogen.
10.
1 oxygen. Got it?
Yes, sir.
Yeah, that's why the small thing you have to remember. Next. To this one. Then we'll go to one more chapter, biomolecules.
B is a ketone, sir, because it does not get tolling test.
He says non-cyclic, remember. That means open chain. They are the carbonyl, means aldehyde or ketone. But among these A and C are reacid
Gives
tolerance
tolerance
reagent.
test.
That means they are
Aldehyde.
aldehyde. And this one, B does not give.
Ketone.
B is a ketone. Yes, you got it. Got it. So B should be ketone. And what is the molecular formula? C4H8O. Means how many carbon atoms you are having?
4.
4 carbon. So let us write the first molecule, aldehyde. 4 carbon atom. We can write it like this: CH3, 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 CHO. See whether 8 hydrogen atom is there.
Yes, sir.
Is there now? Then B should be ketone. You should not give a Tollens reagent test. CH3, CH2, CO, CH3. See whether it matches with that one. You should have a 8 hydrogen atom. Is there? Next, I will write C. C should again be aldehyde. CH3, CH, CH3. We can write it as what? CHO, CHO. Is it 8 hydrogen atom is there? Yes, sir, 8 is there. Then he says A and B on reduction with zinc amalgam and HCl. What is this reaction? Clemenson's reduction. You know that in Clemenson's reduction, A and C both should become hydrocarbon. Should become?
B, A and B, sir.
Yes, A and B. What he says, A and B on reduction with zinc. Because A and B also, because B is also undergo Clemenson's reduction. All of them undergo Clemenson's reduction. Because what is Clemenson's reduction? Both aldehydes and ketones can be converted into
Hydrocarbon.
So you can take all the three, no problem. How many carbon they are having? 4. So that means I should get butane. Butane. Butane, sir. So this is the structure of ABCD. Structure of ABCD. Got it?
Yes, sir.
Check it out. Sir, aldehyde. Yes, sir. Tollens reagent reacts. Sir, C reacts with Tollens reagent. No reaction with Tollens reagent. Right, sir. It undergoes Clemenson's reduction. Yes, sir. It gives you hydrocarbon. Right. So the first part is done. What is the second part? A, B, C are isomers. Which one is least reactive towards HCl?
B.
Very good. B. Why?
Ketone.
Ketone, sir. Because aldehydes are more reactive than ketone. So B is the answer. Got it?
Yes, sir.
Now, like this, there are many questions are there. Okay. Let us take few from carboxylic acid. What is the APC name?
Two hydroxybutanoic acid.
Yes. 1, 2, 3. 3-hydroxybutanoic acid. So 3-hydroxybutanoic acid. So this is 3-hydroxybutanoic acid. Next. What is this molecule? Always UH should be given, should be first priority. 1. Then both are at same place. Then who come first?
Bromo. Alphabetic
Bromine.
order.
1, 2, 3, 4, 5.
3 bromo, 5
3 bromo, 5 chloro, benzoic acid.
benzoic acid.
What happens when methyl benzene is oxidized? What is methyl benzene? CH3. And always remember, not one carbon. You may be having thousands of carbon. When you do oxidation, only the first carbon undergoes oxidation to form what? Fuel. So we get benzoic acid.
Yes, sir.
Next. Arrange the following compound in the increasing order of their acidity. Very simple. So electron withdrawing group, already we have discussed, increases acidic nature. Electron donating group, so it decreases. So what you are having here, this is your carboxylic acid. Sir, we are having extra fluorine and chlorine is there. And they are withdrawing groups, sir. But fluorine is more electronegative than chlorine. So, decreasing order if you write, FCH2COH is more, sir, than ClCH2COH, which is more than acetic acid. But he is asking what? Increasing order. What is increasing order? Ulta. From lowest to highest, sir. CH3COH is lesser than ClCH2COH, which is lesser than FCH2COH. Like this. See, give simple chemical test to distinguish between benzoic acid and phenol. What is the test we can give? Very simple is sodium bicarbonate. What will happen? Benzoic acid
Sir,
degrades
ferric
carbon
chloride.
dioxide. Phenol, sir, no, because it's a weak acid. Yes, what you told is also right. You can take what? Ferric chloride. So it gives a violet color. With phenol, no color either. Or buff color also sometimes. So you can take both sodium bicarbonate and ferric chloride test. Which reagent is required here? A carboxylic acid is converted into what? Amide. What is required then? Very simple. Sir, ammonia. Ammonia is required. Where what will happen? OH is replaced by NH2. Name the reagent used here.
KMNO4.
You have to use, if you use only KMNO4, no. It's only oxidation. Then you end up getting benzoic acid. But what you got here? Potassium. So you have to add KOH. So you have to add, sir, KMNO4 is also required. And KOH is also required. Write the product of the following reaction. I already told you. NaOH and CO means what? Soda lime. And why we use soda lime? Removal of carbon dioxide. So what do you get? So CO,
CH4.
Na is removed. So you end up getting CH4. Here, what is this reaction? When you use bromine and phosphorus, the phosphorus comes and carboxylic acid is there. It is L-Vollard-Jansky reaction. What is that? I told you. Alpha hydrogen is replaced by halogen. Here, which is the halogen?
CH3 Br, sir.
Br. CH2Br, COH. How will you convert the following? Ethanol to 2-hydroxypropanoic acid. This is easy. I already told you. Any carbon on benzene, when you oxidize, becomes benzoic acid. How to convert ethanol to 2-hydroxypropanoic acid? How to convert? Anybody? What is ethanol? CH3, C double bond OH, no? This you treat it with HCN. I told you nucleophilic addition reaction. What will happen? Sir, CN will attack carbon. You get CHOH, and here you get CN. Then what you do? Subjected to
H2O.
hydrolysis. Then this bond will break. The cyanide bond will break. So what will happen with that? You get CH3, CH. When the cyanide hydrolysis, so you get OH always. And CHO and OH. And this becomes COOH. Carboxylic acid. How it becomes carboxylic acid, sir? I will tell you how it is. You take 2 OH minus, H plus and OH. The N combines with H. The N combines with H to become NH3. It becomes NH3. What is remaining? The C is remaining. OH is remaining. The COH becomes. And this is 1, 2, 3. So what you get? 2-hydroxy. This is OH.
Sir, OH? Yeah. Okay.
Yeah. OH. Here OH is there now.
Yes, sir. Yes, sir. You missed it. That's what I was gonna say.
2-hydroxypropanoic acid. Can I tell this?
C6H5CO.
Is oxidation, is it not? So you get benzoic acid. So we get benzoic acid.
KOH is
And
also
it
there,
says
sir.
KOH. So it becomes what? So it becomes COOK. Salt it becomes. Potassium benzoate. Potassium benzoate. Then again it says hydrolysis. Means, say I'll take HCl. What will happen? K combines HCl to form KCl. Again you get back benzoic acid. And what is this reaction? Bromine in presence of ferric bromide means it is a ESR, electrophilic substitution. What is the electrophile? Br plus is the electrophile. And tell me whether it goes to ortho or meta or para.
Meta.
Meta, why? COH is there.
Deactivating.
Very good. Deactivity means it is a meta. Meta means what? It should go to place 3. If this is 1, place 3 is 1, 2, 3. 3. Here Br should come. How do you convert the following? Ethanol to propanol. What is ethanol? CH3CHO. Now I have to convert it into propanol. Means from 2 carbon, I have to make it as 3 carbon. How to make it? Anybody?
Same that acetone, sir. Ethanol to acetone, same that one.
Very simple. Treat with Grignard reagent. CH3 MdBr. You know that one. When all the acetonide combines with Grignard reagent, it gives you what? Secondary alcohol.
Propanol.
Very good. You end up getting propanol. And you know that when secondary alcohol are oxidized, you get ketone.
Propanone.
You get propanol. CH3COCH3. That's it. Done. This already we have done now. Turn into benzoic acid.
Yes, sir.
Oxidation. Next. Aromatic carboxylic acid do not undergo product craft reaction. Why? Then you should know what is a product craft reaction. What is a product craft reaction? I told you always. Already I told you. What is that? You should remember aromatic compound that react with acyl halide to form acyl aryl compound in presence of aluminum chloride. Why it does not give aromatic carboxylic acid? Because the COH group will react with aluminum chloride. It should not react. So it should react with aluminum chloride. So it will not give. Then pK of 4-nitrobenzoic acid is lower. Why? I told you already.
Because NO2 is electron withdrawing.
Ka if it is more, or if pK is low, that means it is more acidic. And we know that NO2 group is a withdrawing group. It increases acidic nature. When acidic nature increases, Ka increases or pKa decreases. pK decreases. Means pK value decreases, lower. Lower the pKa, that means it's a more acidic. More acidic. Why means you have to say, so nitro group is there, is a withdrawing group, it increases acidic. So, shall we move on to biomolecules? This is last year they have taken question. Let's take this. Write the product of the following reaction.
Wolf Krishnan, was it this?
Very simple. Again, same thing, no? O combines with H2 to form what? H2O. What do you get? Cyclohexane, double bond. Sir, NOH, oxime. So we get oxime, sir. Then benzaldehyde with a concentrated NOH. What is this reaction? Canisterous reaction. So what do you get? Alcohol. What is alcohol? C6H5 plus CH2OH plus salt. What salt? C6H5. Sir, NaOH you have taken. So I get Na. Then chlorine and phosphorus. I told you, HVZ reaction. So what you get? Sir, alpha hydrogen is replaced. What is alpha? Here, sir, one chlorine will come. Over. Next, give simple test to distinguish between benzaldehyde and benzoic acid. Which test we can
Toluene
take?
test.
NaCO3.
Benzoic acid. Very good. NaCO. Sir, benzaldehyde will not react, but a benzoic acid liberates carbon dioxide. Propanol and propanol.
Tolerance.
Tollens reagent. Why? This is aldehyde. It will give. This is a ketone. It will not give. Over.
So A, we
What can we
can't go
get?
over toluene test. First one.
First one is sodium bicarbonate test.
Toluene, it can't go do, sir.
Yeah, tolerance you can take. You can take, but it's not very proper. This is very easy to do. Because
Okay.
just liberation of what? Carbon dioxide. We call it as effervescence. Is it enough? We'll go to one more molecule.
Yes, sir.
Biomolecule. Again, in organic chemistry, this is the next highest marks getting chapter. What we have to study here? Carbohydrates first we have to study. You should know what is carbohydrates. What is a carbohydrate? Don't forget the definition.
Polyhydroxyaldehyde.
That's it. Polyhydroxyaldehyde, polydroxyketone. That's enough. Next, the classification. Based on number of sugar in it, but then based on sweetness. Classified as monosaccharide, oligosaccharide, polysaccharide. Monosaccharide again, based on carbon atom. Classified as trioses. Remember the example. This is the simplest carbohydrate. Glyceraldehyde. 4 carbon. Tetroses. Example. Erythrose. Pentoses. Hexoses. Ectoses. Oligosaccharide is again classified as disaccharide if it is having a 2 sugar in it. 3 means trisaccharide, raffinose. Polysaccharides are of 2 types: structural, which provides support and protection; storage, which acts as a fuel molecule; starch and inulin. And this again monosaccharide. And this is about disaccharide, trisaccharide, and tetrasaccharide. And this is about structural polysaccharide and storage polysaccharide. You can take a screenshot if you want. And remember the examples, very important. So structural polysaccharides, cellulose in plant, chitin in animal. Storage, starch in plants and glycogen in animals. Then based on sweetness, this is very important. So they're classified into sugars and non-sugars. Sugars are sweet in taste. Remember this one. And again, based on reducing property. Sir, based on reducing property, they classify reducing sugar and not. And among the molecule, which is most sweetest in nature? Sucrose is, if you take it as 100, if you give the most sweetest 100 means if you give, in fact, fructose becomes 170. So who is more sweeter? Fructose is more sweeter. Remember this. It's sweeter than sucrose. And this is the difference between reducing sugar and non-reducing sugar. Very important. So what is the reducing sugar? The free functional group. They reduce tolerance reagent. They reduce spelling solution to red precipitate. They reduce Benedict reagent to red precipitate, glucose, maltose, lactose. Non-reducing, just opposite. Example, sucrose. Sucrose is a non-reducing sugar. And what is the composition of these particular reagents? Please remember. So tolerance reagent, ammonic silver-nitrate. Spelling solution, NaOH and copper sulfate. Benedict reagent, again copper sulfate, sodium citrate, and sodium carbonate, Na2CO. Sir, how to elucidate the structure of glucose? This you know that. Sir, how do you know that there is a 6 carbon and straight chain? By reduction reaction, sir, we get N-hexane, and this will tell us that it is having a straight chain and 6 carbon. And acetylation tell us that it is having a 5OH group. And how do you know that it is having a carbonic group? We don't know. It may be aldehyd and ketone. How do you know that? React with HCN to form cyanoatine. Reacts with NaOH2H to form oxime. So this is the reaction of aldehyd and ketone. So we know that aldehyd and ketone. How do you know that only aldehyd is there? That is by oxidation with bromine water. What you get? You get gluconic acid. Here what you get? CH2OH. This is called as gluconic acid. It's oxidation with bromine water, weak oxidizing. So this shows that glucose has a aldehyde. How do you know that? It is having a one primary OH group. How many primary OH group? One primary OH. Because upon oxidation with nitric acid, I get glucuric acid. Other name is saccharic acid. And this reaction proves that glucose is having one primary OH group. So by using all this information, I read the structure of glucose. And it is having 5 OH group. In that, one is primary, all 4 is secondary, one aldehyde group is present. This is called the open chain structure of glucose. Then, but this open chain structure cannot explain all the property of a glucose. That is called as limitation. So this is the limitation. It does not give pink color with skip, does not form white crystals with sodium bisulfite, does not react with Grignard reagent, does not explain mutarotation. Why glucose forms alpha and beta methyl glucoside with methanol? We don't know why. Pentaacetate of glucose does not react with hydroxylamine. So we are not able to explain all the properties. So scientists have proposed few more structure of all the glucose, and these structures are known as Fischer ring structure. If OH is present on right side, we call it as alpha, and if OH is present on left side, we call it as beta. So now we are having 3 forms: open chain form, alpha form, beta form. If you put a alpha into water, immediately in water, they dissociate and they form alpha form, open chain form, beta form. If you put pure beta into water, immediately they dissociate to form alpha, open chain, beta form. So in three form, glucose exists nowadays. Remember this part. So these are the open chain form. So this is Fischer ring structure. Fischer ring structure can also be written as our structure or pyramidal structure or a six-membered ring we call it as. Why six-membered rings, sir? 5 carbon is there. 1, 2, 3, 4, 5 carbon is there. Plus 1 oxygen is there. Totally 6-membered rings. So this is the structure of a open chain structure of glucose. Remember this one. This is our structure. And most of the textbook, they give a name like this. They call it as alpha D plus glucose. What is alpha? It indicates anomers. D indicates configuration. So plus indicates optical activity. And these alpha and beta are known as anomers, we call it as. What is anomers? Monosaccharide which differ in configuration at anomeric carbon. This is the anomeric carbon. First carbon. The carbon carrying function of group. This is anomeric. What is the different configuration? So here OH is on right side, alpha. OH is on left side, beta. This alpha and beta is called as anomers. So what is epimers? So epimers means they differ in configuration at any carbon atom. So for example, mannose and glucose are epimers. Why? So they differ at second carbon atom. Observe here. Here in a mannose and second carbon, H is on right side. Whereas in glucose, OH is on right side. So they differ at second carbon. That's why they are called epimers. Like that. Glucose and galactose are epimers. Why, sir? They differ at fourth carbon atom. They are called as epimers. So this is the structure of glucose and fructose. Fructose exists always in a, remember this one, pyranose form. That means 5-membered ring. Again, alpha and beta are called as anomers. And glucose can be prepared by breaking starch also and by breaking sucrose also. That is called as hydrolysis. From sucrose hydrolysis and from starch hydrolysis. What is configuration, sir? This is very important. D and L configuration, we call it as. The capital D and L, remember this one, indicates configuration. What is configuration? Configuration means it is arrangement of H and OH. So it is all about arrangement of H and OH around the carbon atom. We call it configuration. While giving configuration, we take glyceraldehyde as a reference. Is the reference point. If OH is present on the right side of the chiral, we call it as D. If OH is present on the left side of the chiral, we call it as L glyceraldehyde. So if one at one chiral is there, we can tell it. But many are there. For example, like this glucose. So these are all chiral. Star mark is chiral. What is chiral? They're attached to 4 different groups. Look at here. These are chiral. Why, sir? You're having 4 different groups. And that carbon is called as chiral carbon atom. So one is there means we can tell it. But if many are there, what do you have to do? Penultimate. What is penultimate, sir? Last but one you have to observe. And see, if OH is on right side, it is a deconfiguration. Last but one you have to observe. If OH is on left side, it is a L configuration. That's it. This is how we get D and L configuration. Remember, in nature, most of our food, all the food is present in D configuration because the enzyme in our body can recognize only D configuration. And remember, these glucose, fructose, mannose, they can isomerize with each other. They are isomers. They can be interconverted in presence of a basic medium that we call it as a Eckstein rearrangement, or we can call it as isomerization, or we can also call it as enolization. This happens only in a basic medium. And glucose can react with phenylhydrazine to form osazone, we call it as. How many phenylhydrazine required? 1, sir, 2, and here 3. So we require 3 molecules of phenylhydrazine. Mutarotation. Change in optical activity we call it as mutarotation. Means, say alpha D glucose is having 112 optical activity. When you put it in water, it slowly changes to 52.5. Same way, beta is having 19-degree optical activity, means dextrorotatory. If you leave it for some time, slowly it changes to 52. This change in optical activity is called as mutarotation. Only glucose will give, lactose will give, maltose will give, but sucrose will not give. So sucrose will not give because in sucrose there is no alpha and beta. And what is the percentage of this alpha and beta? Please remember. Only beta is major, sir. 64% of glucose exists in beta. 36% is in alpha. And open chain is less than 0.0%. And if you take disaccharide, these are the important disaccharide, maltose, lactose, sucrose. In sucrose is made up of glucose and fructose. Linkage is C1 to C2. Whereas in maltose and lactose, it is C1 to C4. This is the structure of a maltose, structure of a lactose, where first one is a galactose and then glucose. And this is alpha lactose, means beta galactose and alpha glucose. This is the structure of a sucrose, where glucose and fructose is connected with C1 and C2. Remember this. That's why function group is not free. It is not a reducing sugar. It does not undergo mutarotation. It is also called as inward sugar because the optical activity of a sucrose is means dextrorotatory. But when you break it, it becomes glucose and fructose. You know that fructose becomes minus 92, and fructose becomes plus 52. So overall, it becomes levorotatory, means it becomes opposite. That's why it is called as inward sugar, we call it as. Then this is the structure of a polysaccharides. The first one is cellulose, made up of beta glucose, and the linkage is, remember, C1 to C5. Then this is starch. In starch, there are two components, amylose and amylopectin. In amylose, it's a linear. Okay, remember this one. Amylose is linear. Linkage is C1 to C4. Whereas amylopectin is a branched component. Linkage is between C1 to C4 and C1 to C6. Cellulose is made up of beta glucose. Again, linkage is C1 to C4, made up of beta glucose. You gain a linear one. And glycogen is a storage polysaccharide. It is a branching molecule. Remember this one. C1 to C4 is also there, C1 to C6 is there. But here more branching is because it takes place for every 8 to 10 glucose unit. Branching will take place. So it is having a more branching. Then coming to amino acids. Okay. Amino acid means they're made up of both amino group and carboxyl group. And they're the one which makes protein. Here, the R group is a side chain. And this carbon we call as alpha carbon. So NH2 is attached to alpha carbon. So these amino acids are also known as alpha amino acids. And there are many kinds of amino acids. Are there many amino acids? There mainly two types: protogenic and non-protogenic. Protogenic means these are the ones which are involved in making protein in all plants and animals. So there are only 20 standard amino acids. So we call them as a protogenic standard. There are many amino acids, but protogenic is only 20. And these are the 20 amino acids. You have to remember the structure, please. All of you have to practice. So the few things important I will tell you. The glycine is a neutral amino acid because it is having one COH group and NH2. Phenylalanine is the aromatic amino acid because it is having a benzene ring. Like that. Say serine is a OH containing amino acid, hydroxyl group containing amino acid. Serine and threonine are. Cysteine and methionine are sulfur containing amino acid. Cysteine and methionine both are sulfur containing amino acid. Aspartic is we call it as acidic. Why is that acidic? Because they have a more COH group. That's why they're called as acidic. Lysine is basic. Why basic? Because it has a more NH2 group. That's what is basic. So chlorine and this aspartic, chlorine is called as heterocyclic amino acid. Why? So cyclic ring is having different element, and also NH is called as amino group, sir. So it is also called as amino acid. So histidine, tryptophan, these are again heterocyclic as well as basic. Hetero, because they have a heterocyclic ring. That's why we call it as heterocyclic amino acids. And based on nature, you can classify the amino acid as neutral, acidic, and basic. Basic means they have a more NH2 group. Based on structure, we can call it as aliphatic, aromatic, and heterocyclic. Aromatic means they have a benzene ring. Heterocyclic means they have a different element in cyclic. This is very important. Essential amino acid and non-essential. Based on nutrition, we can classify. Essential means that we require it in diet. That we call as essential. So there are 10 essential amino acids. You can just remember one code, AVLMPTT. A stands for arginine, valine, H stands for histidine, I stands for isoleucine, leucine, glycine, like that. So there are 10 amino acids. Other than 10, everything else is a non-essential. What is non-essential? Our body can synthesize, not required. So not required in diet. And there are many questions on this nutrition, based on nutrition. So what is a deuterion? So amino acid possessing both negative charge and positive charge, we call it as deuterion. So What will happen to amino acid at acidic condition? They keep on asking. Acidic condition means pH 2. So they become a cation. At basic medium, at say pH 10, so they become an anion. In between, they exist as cation and anion. We call it as deuterion. And that point is also called as isoelectric point. We call it as Pi. What is the isoelectric point? It is a pH at which amino acid exists as a deuterion. And amino acid combines to form proteins or peptide. If 2 amino acid combine, you get a dipeptide. If you have 3 amino acid combine, you get a tripeptide. If 4 get tetrapeptide. Like this, many amino acid combines means we get polypeptide. And these polypeptides are nothing but proteins. And proteins are again classified into mainly fibrous protein and globular based on shape. Fibrous are linear, thread-like. They're insoluble in water, like keratin and myosin. Globular are spherical and they're soluble in water. So based on composition, you can have it as simple, means only amino acid will be. Conjugated, sir, amino acid as well as non-amino acid component. So this is very important. Structural organization in proteins. There are 4 structures mainly. Primary. What is primary? The sequence, linear sequence of amino acids. Secondary means the primary structure fold upon itself to form an alpha helical and beta pleated sheets. So what is tertiary? Secondary structure fold upon itself to form 3-dimensional structure called as tertiary, we call it as. What is quaternary? This takes place in a protein containing more than 1 amino acid chain. Otherwise, it will not. So again, the same structure. The linear sequence is known as primary. If it fold upon itself, we call it as secondary structure. If secondary structure fold upon itself, we call it as tertiary. And if free structure is there, then only we call it as protein is biologically active. If secondary and tertiary is lost, we call it as denaturation. This is a primary structure, and primary structure fold upon itself to form secondary. Secondary may be, as I told you, it may be alpha helical also, like this helical structure, or it may be beta sheets also. And they have a hydrogen bond and covalent bond. This is a alpha helical structure. These are beta pleated sheets, which can be parallel also, anti-parallel also, held by hydrogen bond. And they fold upon itself to form a 3-dimensional structure. We call it as a tertiary structure. And if a secondary and tertiary structure is lost due to any physical or biological or chemicals or due to nucleic radiation, we call it as a denaturation of protein. Little bit of nucleic acid you should know. So what is a nucleic acid? It's a polymer of nucleotide. So what is a nucleotide? It is made up of nucleoside and phosphoric acid. What is nucleoside? It's made up of nitrogen base and sugar. Sugar is of 2 types, ribose and deoxyribose in DNA. Pyrimidine bases of 5 types, cytosine, thymine, and uracil are pyrimidine. Adenine and guanine are purine. So in DNA, we have a deoxyribonucleic acid. RNA, we have a ribonucleic acid. So these are adenine and guanine and cytosine, thymine, and uracils. So this is the one structure of a particular nucleoside, which has a nitrogen base as well as sugar. C1 will be connected to 9th nitrogen atom. So this is the structure of a nucleic acids where nucleotides are joined to each other. These are nucleotides. This part is called as nucleotide. They're joined through which carbon atom? To put a third carbon atom to fifth carbon atom. That's why when we say DNA strand, we say 3' to 5', or we say 5' to 3'. And this is the complementary base pairing in DNA. So adenine binds with thymine with 2 hydrogen bond. Guanine binds to cytosine with 3 hydrogen bond. And Chaga proof says that amount of purine is always equal to pyrimidine base. And in hormones, we have 3 types, mainly steroid hormones. Steroid hormones are mainly sex hormones. All sex hormones are steroid hormones. Important for development of secondary sexual character. Then we have amino acid derivatives. Amino acid derivatives. These are mainly thyroxine hormones called T3 and T4. Then you're having peptide hormones or protein hormones. Means they're made up of many amino acids. Not one, many. That's why we call peptide hormone. For example, insulin, which regulates our blood sugar level. They're made up of 51 amino acids. Oxytocin, which helps in contraction of uterus muscle in mother, 9 amino acid. We call it as anti-diuretic hormone. That is also made up of 9 amino acids. Let us take some questions in that one. Okay. Vitamins, I have to tell you. I forgot vitamins. So in vitamins, there are 2 types. We call it as a micronutrients required in a small scale, but very vital for overall development. There are 2 types of water soluble and fat soluble. Fat soluble are, A, D, E, K are fat soluble, and C and vitamin B are water soluble. So A is called as retinol. It causes blindness. D is called as calciferol. So it causes rickets and osteomalacia. E is called as tocopherol. Causes sterility and mother weakness. K is called as phylloquinone. Causes delayed blood clotting. You have to remember the disorder, that's it. So B1 is called as thiamine. It's causes beriberi. B2 is riboflavin, causes thyrosid. So B3 is niacin, causes pellagra. B6 is pyridoxine, causes convulsions. B12 is cyanocobalamin, causes anemia. So C is called as ascorbic acid, causes scurvy. Please remember the deficiency disorder of all these vitamins, nothing else. Let us see how the questions have been given. Which of the following statement is not correct? What may be the option? All hydrogen bonds in secondary structure or proteins are intramolecular. Right-handed helix is stable. There are 3.6 amino acid residue per turn of the helix. Sir. So what may be the wrong? The hydrogen bond in alpha helix are perpendicular through tappagutte. Yake sir? If this is the alpha helix structure, ಬಾಂಡ್ ಹೆಂಗಿರುತ್ತೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡು ಸರ್ ಇಲ್ಲಿ CO ಗ್ರೂಪ್ ಇದ್ರೆ ಇಲ್ಲಿ ಏನಾದ್ರು NH ಗ್ರೂಪ್ ಇದ್ರೆ ಅವೆರಡು ಮಧ್ಯೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಇರುತ್ತೆ ಹೆಂಗಿರುತ್ತೆ ಹಾಗಾದ್ರೆ ಸರ್ ಪ್ಯಾರಲಲ್ ಟು ಆಕ್ಸಿಸ್ ಇದೆ ಸರ್ this is not perpendicular this is parallel to axis Which one of the following statement about protein is wrong? Protein occur in non-living cells. Proteins generally contain nitrogen. Hydrolysis of protein in acidic aqueous solution results in formation of amino acids. Their solubility reach maximum ಅಂತ ಹೇಳಿದ್ರೆ ನೈಸರ್ಗಿಕ ಪಾಯಿಂಟ್ ಯಾವ್ದಾಗುತ್ತೆ ಸರ್? The fourth one is wrong, sir. It's a minimum at isoelectric point. Which of the following statement is not correct? Tertiary structure of protein is three-dimensional. In globular proteins, nearly all the hydrophobic groups are hidden inside.
Third one wrong, sir.
And polar groups are present on the surface, resulting into spheroid shape. Only hydrogen bond is involved in tertiary structure. Yes, third one is wrong. Match the following. Which are epimers?
Glucose and
Glucose and mannose are epimers. So second option ಆಗುತ್ತೆ. Which are anomers? Alpha and beta are anomers. That is third one. Enantiomers. These are the mirror image, but not superimposed. One, sir. And glucose and fructose are functional isomers because glucose has a aldehyde, fructose has a ketone. So it should be 2, 3, 1, 4.
1.
Sir, option 1. Next one. Glucose is treated with dilute NaOH. It gives mixture of D-glucose and what? Sir, I told you, in a basic medium, glucose will isomerize to give what? Fructose also, mannose. It's called as enolization, isomerization, Ekenstin rearrangement. What will be the option? So glucose reacts with HI. It forms NHane. So second option. Glucose reacts with phenyl so gives hosazone. Third option. Glucose reacts with bromine water. Gluconic acid. Glucose reacts with HNO3. Saccharic acid. 2, 3, 1, 4.
Second option.
Second option. Yeah, what will be the option? So sucrose made up of glucose and fructose. Lactose made up of glucose plus galactose. Maltose made up of glucose. Raffinose is a trisaccharide made up of glucose, fructose, and galactose. 2, 3, 2, 1.
4, 1. 2, 3, 4, 1.
2, 3?
4, 1.
4, 1. 2, 3, 4, 1. Yeah, what is the option?
Third one.
Fourth option. Third option, sorry. Glucose is a aldose. Fructose is a ketoexose. Arabinose is a aldopentose. Erythrose is a aldotetrose. 2, 1, 4, 3. Fourth option. What is the option? Cane sugar means Sucrose.
Sucrose.
Inward sugar means mixture of glucose and fructose. Grape sugar means
Glucose.
glucose. Milk sugar means lactose.
Lactose.
3, 4, 2, 1. Second option. Disaccharides that are reducing in nature are
Lactose and maltose.
reducing. Very
C.
good. Lactose and maltose. Because sucrose is non-reducing
Non-reducing
sugar.
sugar.
Which one of the following reaction is not explained by the open chain structure of glucose? Sir, first option. Which
Yes,
of the
sir.
following reaction is not explained by open chain structure of the? Oh,
Glucose.
that's not the first option. What is the option? Last option. This you cannot explain. When glucose reacts with methyl alcohol, it gives you alpha and beta structure. And that they cannot explain. Which of the following statement is correct about sucrose? Correct about sucrose.
D, sir. Laboratory nature.
It is not levorotatory. Sucrose is having a positive 66 degree dextrorotatory. So first option cannot be. He says it undergoes mutation. No, sir, no mutation. It is levorotatory. No, it is a dextrorotatory. What is the option there? C, sir. Which one of the following is a disaccharide?
Maltose.
Maltose is a disaccharide. Starch is a polysaccharide.
Yes, sir.
Which of the following is a polysaccharide?
Starch.
Starch is a polysaccharide. What are reducing sugars?
Undergoes Tollens and Fehling's test and free functional group aldehyde.
Yes, that's enough. They have a free functional group. So they have a free functional group. They reduce tolerance and Fehling's solution. Glucose on reaction with HI gives NXN. What does it suggest?
It's a straight chain carbon.
So there are 6 carbon atoms, and all 6 carbon atoms are in straight chain.
Straight chain.
Next, what product is formed when glucose reacts with HI?
And
There only
hexane.
it is the answer.
Yes, sir.
NXane. What is the product formed on reaction of glucose with bromine? What?
Gluconic acid.
Gluconic acid. What is the structure? You have to show it like this. CHOH 4 times. CH2OH. Only aldehyde undergoes oxidation, sir, to form COH. CHOH 4 times. CH2OH. Yes. Shall we stop here? We'll continue from tomorrow.
Yes, sir.
tomorrow we will take, in addition to this, we'll go for inorganic and physical. Huh?
Yes, sir.
Yeah,
Thank you,
okay.
sir.
Thank you then.
Thank you so much, sir. Thank you, students, for joining.
Thank you,
So
sir.
tomorrow
Thank
also
you,
we
sir.
have the same class from 4 o'clock till 8 o'clock.
Yeah.
So,
Okay.
so can you tell the students now itself like what tomorrow you're going to take the class?
Yeah, I told them. Today we have discussed organic. Tomorrow we'll take physical and inorganic.
Okay.
Yeah, right.
Okay, sir.
We'll
Sir,
continue
could
from
you-
this point. We'll go to physical and inorganic.
Okay.
Could
Any
you
doubts?
send us, could you send us these PPTs in the group, so it would be really helpful for us?
Yeah, definitely. I'll take it from the professors and I'll send it in the group.
Yeah, I'll send you
Yes,
one.
sir.
No problem.
Thank you.
No problem.
Okay,
Thank
sir.
you,
So you
sir.
can WhatsApp
Thank you,
me.
teachers.
Yeah, right.
Yes, sir. Thank you so much, sir. Thank you,
so much,
students.
sir.
Please join tomorrow at 4 o'clock.
Yes, sir.
Yes, sir.
Okay. Yeah. Bye. Good night.